I hope you can hear me. I hope you can see me. We're having a bit of issues, you know, the little goblins in the computer or whatever else is in the computer. But it's a new tool that we're testing. Some of you already know it. It's um, it's basically Microsoft Teams, and it's a PowerPoint, but even that sometimes doesn't work together. So the next slide, please. We're doing it the old-fashioned way. So if you're a speaker, the next slide will work. So basically, if you have some of these pictures are no longer feasible because we're just sharing the screen. But if we were doing it another way, you could see it better. Basically, if you are a participant and you have a question, basically just put your mouse cursor on the little bubble that says chat and put your questions in the chat. Don't forget to mark who exactly are you asking the question towards. So to give you an example, my name is Dan Stefanica. I'm the, let's say, host of you today. If there's a question for me, just put @Dan and put your question there. Then there's also an option next to the chat. It's called reactions, and it has some, thumbs up, hearts, applause, and all sorts of things. If you would like, I don't know, in a special case, you would really, really like to not ask your question in the chat, but you would really, really like to ask it live, raise your hand and we'll see if we have time to do that. Okay, next slide, please. Thank you so much. So as you can see, the recording has started. Transcription, probably not, because I didn't enable that. But just in case, it might be that the transcription has started as well. Usually you would be able to click on the links. So if you would see a link in the PowerPoint, you would be able to just click on it. Unfortunately, with sharing the screen like this, that would not work. Next one, please. Okay, basically this doesn't work anymore. Next slide, please. Okay, so let's go through the agenda while we bear with these little, technical problems. So welcome and meeting logistics. I'm doing that now. Rest assured, I can see your messages and I will grant access to everyone. Then we will have the role of the Innovation Fund, a presentation by Maria Velkova and her colleague Evelina Daniel. We will talk about REPowerEU and the heat pump sector in particular by my colleague Josephine that is there. Then we'll go to general observations of the application process, weighing criteria and focus. Basically, this will be from our colleagues at EJEC. Sanjeev Kumar will be doing that. Then for almost an hour, a very interesting panel discussion moderated by our Secretary General Thomas Novak. This is basically with all the key developments, the challenges, the opportunities, everything to do with the heat pump sector and how they relate to the Innovation Fund with the investments that are needed. And basically all the future aspects and future opportunities that exist in our sector. And of course, all the things that the Innovation Fund can provide for our sector, but for the renewable heating and cooling sector in general. The panelists are Jose La Loggia, Drew Turner, Patrick Crombie, Alex Chambres, Marco Baresi. Then we'll have a little virtual coffee break and we will try to put you some little videos. So when you make your coffee or you're stretching your legs, you get a little bit of music and a little bit of more information about heat pumps in an animated way. Next slide, please. We will try. Usually that works. Then, of course, we will talk about the project presentation. So we have 5 project presentations. We have from Drew Turner, from Jose La Loggia, from Clayton Vickers, from Marco Baresi, and from Parfait. I am going to attempt to say your name, Parfait, Tasijong. Group discussion on the design of the clean tech window will be moderated by Evelina Daniel with the panelists that were in the project session. Then we have a closing of the event done by Philippe Dumas from EJEC. And then the end of the event, and hopefully everything will go well. The end of the event will just be me thanking everybody, including my neighbors that have cleaned their apartment with the vacuum cleaner earlier in the morning and not during our session. So Big thank you to them. Next slide, please, will be Evelina Daniel actually sharing her screen, just because there are small changes in her slide. Please, Evelina, do your best. If the platform crashes, I will blame it on the weather. Yes, we can see it like you had it before, centered.
Okay, very good. Good afternoon. If the presentation is visible, then I let my colleague Maria to start.
Thank you, Evelina. Thank you, Dan, and thank you everybody who has joined this very interesting and useful workshop, I hope, for everyone. For us, for sure, it will be very interesting to hear all that will be presented by projects and all your thoughts about the Innovation Fund, the needs of the sector and the projects. So just to clarify one small thing, Evelina Daniel is actually also from DG Climate Action. We stole her from DG Energy, so we are in close contact with with DG Energy, especially on this important sector of heat pumps. But indeed, the Innovation Fund is actually the responsibility of DG Climate Action. So you will see actually in the participant list, there are some colleagues also from our team in DG Climate Action, Roxana and Carla working immediately in our team, but also colleagues from the implementing agencies, SINEIR, and Chris Mullins, who is a consultant on our methodology on greenhouse gas emission avoidance. And please excuse me if I've forgotten somebody, but we have also invited colleagues from other DGs in case they are interested. I'm not sure they will join. Just to be clear on the setup, before I start with my really very ambitious plan, we have actually, both me and Evelina, an ambitious plan to present to you the Innovation Fund, what we are doing with REPowerEU, and what our questions are to you in 20 minutes. So that is actually the outline of our presentation. And so I will start with really basic Innovation Fund, but I have an expectation, or we have an expectation that you have heard of the Innovation Fund. Maybe you have even tried to apply for Innovation Fund, or at least look at the requirements. So we will be very short, and there's really an awful lot of information available on the website. So if we trigger your interest in Innovation Fund with this workshop, please go on DG Climate Action website, go and check the funding and tenders portal, where we have the call documents for the large scale and small scale call. Small scale call is still open actually, the current one until end of August, so even open opportunities. But back on Innovation Fund, it is actually, one of our biggest instruments to support decarbonization of industry and energy sectors in the EU. It is funded by the emission trading scheme. And even if renewables and heat pumps are perhaps not concerned with paying, with participating in the emission trading scheme, these are actually our, key stakeholders, and they can help us decarbonize both energy sector and energy-intensive industries. That's why they feature so prominent. Production and use of renewable energy is one big eligibility group, if you want, next to energy-intensive industries, next to energy storage, and carbon capture, utilization and storage. So with Innovation Fund, yes, please go ahead, and don't hesitate to push me, because I have 15 minutes max, most probably less by this moment. So with Innovation Fund, we are actually targeting a specific, it is kind of wide, but still specific technological readiness level or commercial readiness level example of technology development. So we're not talking anymore about research, but really proving concepts on the ground. Our ideal actually project is a large-scale demonstrator or first-of-a-kind commercial plant, but there are other actually programs that can help other parts of technology development. And here on this slide, you can see Horizon Europe, there's European Innovation Council, LIFE program for smaller projects and prototypes, there's Connecting Europe facility for infrastructure, and then further on, there's InvestEU. But this is just like a sample of EU programs. And Innovation Fund is really to help this so-called Valley of Death. But yeah, we will want to hear from you. Where is your Valley of Death actually in your sector? Where we can help today? This is what we want to hear from you today. So next slide. These are the key elements of the Innovation Fund or conditions. I will not go into depth here because each box really requires 10 minutes, but you can see it is like with 75 actually euro a ton of CO2, we have 38 billion over 10-year period of the program. The current program spans over 10 years. We are planning annual calls, and this is what we have done so far: 2 large-scale calls, 2 small-scale calls for proposals. The distinction between small scale and large scale is actually the capex. So any project that is having capex of more than 7.5 million is considered with us large scale project. And actually the focus of today is the next large scale call which we are preparing. So think large scale more. If you have any input on small scale, we are of course you're welcome to pass it to us, but in another context when we think about the next small scale call better. So we can actually just 2 more things on this slide. We can support up to 60% of the additional costs related to an innovative technology or the financial gap. We can explain, of course, more, but there is a specific relevant cost calculation, which is actually quite similar to state aid calculation, for example, if you're more familiar with that. But this means that actually there's still quite a lot of money to be found for a project to be realized, because we're focusing our work only on this financial gap. Whereas the work of the project, of course, is to find all the money that are necessary to do the investment. And the second point that I wanted to make on this slide is that we also are able to offer project development assistance. This is for projects that are considered very good, but not sufficiently mature, both on the project maturity criterion. And actually, last point, but that in fact with us, single applicants can apply. So it's not needed that you have a consortium or that you have participation from more member states. A single applicant can apply, but the project has to be situated in the EU, Norway and Iceland. So finishing on that one and moving to the next slide. The award criteria. So it is they are actually explained in our delegated act, which governs all our work. So we have 5 award criteria: degree of innovation, greenhouse gas emission avoidance, project maturity, scalability, and cost efficiency. And on the screen here, you see how these criteria have been applied for the first calls for proposals. We are unlikely to change actually this sub-criteria, but we still want to hear from you in case you have thought to apply. Are there any specific difficulties you can see with one or another criterion in relation to your sector? So next slide. Yes, so REPowerEU plan and the Innovation Fund. Well, this is in a way the reason why we are here with you. You have, if you go, Evelina, to the next slide, we no doubt everybody has heard about REPowerEU. It is, in fact, our Commission's response to the crisis in Ukraine. Our main aim is actually to accelerate the move away from fossil fuels. The REPowerEU plan has many elements, and certainly I'm not going to explain them today. And I believe most probably have read the communication and the action plan, and also the accompanying other communications and plans. But we want to just very briefly explain what this means actually for the innovation funds. So next slide. REPowerEU, of course, it's we are raising the ambition, in fact, accelerating the transition to clean energy and to climate neutrality, if you want. And we have to put some money actually into acceleration of this transition. So there are different elements we call smart investment under the REPowerEU. Like, for example, member states have to think through their recovery and resilience plans and others, but also in the Innovation Fund, because actually we can put more money faster. And this is our plan actually, that with the next call, we will double the next call budget with the aim to accelerate the deployment. On one hand, to have dedicated REPower windows, and I will explain those as well. And also we are actually developing a new tool on carbon contracts for difference. And I'm not going to talk about this today. So next slide. Which is actually now going really into the core of the debate today, if you want. We have already indicated in the REPowerEU plan that we are planning to put the focus on 3 white windows, actually, which are, you can see them in the bullet points, electrification and hydrogen applications in industry, innovative clean tech manufacturing, and where heat pumps are especially involved, because we are thinking here of production of components that are essential for renewable energy and energy storage. So electrolyzers and fuel cells, innovative renewable equipment, energy storage, I said, and heat pumps. And then we have another window, mid-size pilot projects, but I have a separate window because it's important to understand the distinction. These 3 windows come in addition actually to the general code or the general window. So we will keep in a way an open and general window, and we will have 3 dedicated windows. If you go to the next slide. Just to explain why we're doing these thematic windows and what we aim with them. So we don't plan actually to call for specific technologies within the windows. We will still apply a bottom approach within the windows while making clear which project should apply under which window. The aim is actually to cater for these specific policy priorities, because they're very important, and we want actually to award projects that are ready to go in these specific areas, because we think these are really very important to address the REPowerEU priorities. On the other hand, we want to create these windows where actually competition is among like projects. So that's why we are having actually these workshops to understand the project pipeline, to understand your projects, in order to be able to better define these windows in the call for proposals. And yeah, so we may actually, in some our methodologies, need to, like the relevant cost methodology or greenhouse gas emission avoidance methodology, we need to complement them with some specific aspects that are relevant for these windows. So that's on that slide. And next one is yeah, so I think I explained quite a lot already on the setup of the windows. Now, the specific window where heat pumps fall is, well, we can call it clean tech manufacturing or manufacturing of components for renewable energy and energy storage. And the aim here is to develop resilient supply chains, to establish industrial capacity and technology leadership in Europe. And we aim at strategic autonomy. So in a way, we link our work under the Innovation Fund with actually what is written and has been the aim of the industrial strategy or competitiveness strategy of the European Union, if you want. Of course, focus decarbonization. We also want to address the dependence on critical materials, because this may be stopping some of these good technologies from developing. So I already said which are the areas of this window, with focus today on heat pumps. Maybe perhaps important to say is that heat pumps, of course, are very important for renewable energy. So we have to, but in any case, whether it is components for heat pumps or it is defined components for renewable energy, it will be within this window. So projects will not need to really wonder where to apply, because it's this window. So next slide. Yes, so we have actually, just to, maybe I should have said, this is, we are not expanding the eligibility of projects of the Innovation Fund. All these projects I've just described already, the concepts and the policy objectives, all this has been actually possible under the predecessor or the preceding calls for proposals. And we do have some examples, not from the heat pump sector, but we have some examples for clean tech manufacturing, most notably the Tango project, which is from the first large-scale call, which is industrial scale pilot line for production of PV cells in Italy, which is quite big because it's scaling up an existing capacity from 200 megawatts to 3 gigawatts per year. We have under the small scale call also 3 projects which are also falling in this sector of manufacturing of components for built integrated PV roof components, for actually energy storage systems based on second life car batteries, and green foil project, the third one, which is on the slide. It is actually for a specific element in that is part of the batteries, which is the foil in lithium-ion batteries. So it's again a production of this specific element. So these are just examples, but we hope that we will hear from you what can actually come from the heat pump sector, and it's innovative. So we have one slide here on best practices from successful clean tech manufacturing projects. I must say that, well, we have this published actually, and it is available on our website, both for large scale and small scale co-projects best practices documents. I must say that they are no specific actually takeaways for manufacturing projects. In fact, all best practices can be applied for any type of project. And I don't really want to take too much time because it is here, it is really worthwhile a separate workshop to talk about lessons learned and how to improve applications. But maybe one important takeaway is that the key difficulty for projects that are innovative is to reach the project maturity criterion, especially financial maturity criterion, because projects often have a good concept, but they don't have clear enough idea about how to put together a financial plan. So they know they need money, but they don't have quite often a good strategy how to get all the money they need, or what is in fact their market, who is going to buy their products. So project maturity, pay attention to this specific criterion. The other ones are much easier, so long as for projects to meet, so long as they read carefully the context and explain very well, for example, the state of the art and how the project goes beyond the state of the art, that any project that is innovative should be able to do. But I won't spend more time because we just don't have it. And then one slide actually on this third thematic window, which we call mid-sized pilots, just to make sure that you don't get confused by this mid-sized, because there has been a call from projects, from stakeholders, that we should offer funding for smaller projects. Because it is true that any project above 7.5 million is considered a large-scale project. So, and you can see that in the first project selected under the large-scale call, we got really quite big projects, whereas we perhaps didn't fund enough smaller projects. But that is an issue for another discussion. We are looking into that, and the main problem actually was that we didn't have enough money in the first call to fund enough projects, and that's why the money went to the biggest projects, because they were just bigger in impact in a way, so they got biggest higher scores on all criteria. But this window, mid-size pilots, is not actually the determining criterion will not be the size of the grant, but will be actually the stage of the development of the technology. We want actually to be able to support breakthrough innovation and a little bit upstream from large-scale demo or commercial, first-of-a-kind commercial plans. So we're thinking of really pilots here with limited, for example, quite often they will have limited operation time because they're testing a technology. They want to, but they need money that are not available in normal Horizon Europe calls. So still they're quite expensive. They don't have revenues quite often, such pilots. So it's still a very specific type of projects, which are not to be commercial actually. So I hope you don't get confused on that window. But in any case, today the focus is on the manufacturing window. And I think maybe this is all. Yes, no, my last slide is actually on the next steps. So what are we doing here? We are having actually in the space of 1 week 4 workshops to understand better the pipeline for manufacturing, actually for this window on manufacturing. So we will have workshops with renewable energy, with hydrogen and energy storage associations in the space of this week. We have a meeting of our Innovation Fund expert group where all stakeholders are present together with member states to discuss how we see this third large-scale call and specifically the new windows. The aim is actually to launch the call in November. The deadline will be March 2023. We will have, of course, an info day to present the call immediately after launch of the call, together with actually a dedicated workshop on lessons learned. So you will hear how to prepare good application, where to put the focus, how to overcome common weaknesses. We also have a workshop on synergies between Horizon Europe and Innovation Fund end of 22, where we will be looking at Horizon Europe projects that are mature enough to apply for Innovation Funds, because we're working on improving synergies and complementarities between these two programs. And last but not least, the third small-scale call will be launched in April 23. And as I said, actually, the second small-scale call is still open. So we continue with our planning of having annual calls, large-scale and small-scale calls. So that is it on my side, I believe. And now I pass the floor to Evelina.
Thank you, Maria, and good afternoon, everyone. Very happy to be here and speaking from the side of DG Klima, but I've met many of you working indeed 8 years in DG Ener. We are now in the third part of this presentation. I saw that some people were joining a bit later. So here are our questions that we are asking ourselves for the design of this clean tech manufacturing window. Those questions, we prefer to show them right now, because I think that maybe some participants can already answer them, some speakers, when they deliver their presentation. And of course, we have at the end of today we have earmarked, I think, 20 minutes for a very good discussion. So we would be very grateful if you could bring already some feedback to those questions. But then the workshop is not the end of the story. We welcome very much written input to those questions. We would be very happy to receive it. And I think that that here the organizers are the best place to consolidate it and make sure that no message falls through the cracks. So yes, written input is also a possibility. Okay, now I jump into questions. The very first question is relating to the market conditions for the large-scale manufacturing projects for the heat pumps. We want to know what the main risks are, what the barriers to implementation are. In essence, what pipeline can we expect for this thematic window under our third large-scale call? And here I would just, for this question, I would just jump one slide because like Maria was explaining before, for this purpose, we also had the survey. It was running for a couple of weeks. Now we closed that. There were questions exactly on the pipeline of the projects, who would be interested in funding, what kind of funding, what exactly field they operate in. So we have the feedback through the survey. It only closed last Friday, so we are still analyzing it, and we just put 2 slides with the first results. And the question is meant for those who did not participate in the survey, who have other insights on this survey to have a discussion about. So just to talk through the results. So first of all, we received 220 answers to our survey. We had 114 responses from the clean tech manufacturing and 106 from the pilots. Now, interestingly, since the choice of the team was a multiple choice, we had quite a high number, 66 to be precise, projects that were signaling that at the same time they are about clean tech manufacturing and they are being pilots. So this is the category. Now here you can see on the graph selection of areas from that were ticked in the survey. Just be careful, do not add up all the numbers and expect to fall on the 220 because of the multiple choice. So indeed, we see quite high numbers for innovative renewable energy and carriers. Here it was meant hydrogen, components for renewable power generation. We have quite a number of responses for the heat pumps. And the second slide that I would show, and it is still linking to this first question about the project pipeline and the market conditions. From our survey, we see that the type of funding mostly sought are grants. You can see from the first pie chart. And then in terms of the size of the funding, we see that for the mid-size pilots, it is between 25 to 100 million euros. For the clean tech manufacturing, the dominant category is below 25 million. I think it's an interesting finding, but it would be great to hear during the discussion more about that. Now I'm back to the questions. Second question is about eligibility for thematic windows. So here, in essence, we hope that you would help us to define the boundaries of what can be eligible for funding, how far we go into the supply chain, what other related sectors we should consider. So this is for the positive definition, but maybe there are also negative definitions. Should we exclude certain elements? Should we say that if certain critical raw materials are heavily reliant upon, maybe this is not the way to go? So both in a positive sense, how far we should go with the definitions, and also in a negative sense. Now, third question. For the Innovation Fund, we always establish a final financial close and the entry into operation. We have a prescription for this in our, we require the time to reach them. But for this window, and considering the urgency of the REPower action plan, we are wondering how much project pipeline would need time to reach indeed the financial close. This is more or less final investment decision. How much time it would need to enter into operation. Are there many projects which would be able to go faster than what we require as maximum periods? For the financial close, we say it is up to 4 years, but we would be interested to know if there are projects which would be available faster. Now, award criteria. In a way, question 4 and 5 go together. Maria was explaining them earlier in the presentation. Which are those which are the most pertinent, or to put it differently, under which criteria the projects would shine the best, and which would be the most difficult? You already heard that project maturity is the criterion that many applications struggle with, but that is general funding for all our applicants. We wonder if you have insights specifically for the heat pumps manufacturing. I already talked through the survey results. I continue on the questions. Scalability criterion. How much that given technology can develop, how far it can be applied to other markets. So basically, we're asking what is the size of potential market for the products. Do you have already feedback for that? Degree of innovation. This is so to say flagship. I mean, it doesn't have bigger weight, but this is the flagship criterion for the innovation fund, which is about the innovation. And while today we determined that on the EU level, we could, for the large scale call, one could ask a question if for the manufacturing projects, it could be rather member state level, national level, European or global level. Now, going very, very into depth of our methodologies, GHG methodology, the one which enables to show relative and absolute abatement of GHG emissions. We can tell you that today, certain elements, certain part of the certain abatements are excluded from the scope of calculation, such as emissions from manufacturing of machinery, emissions due to manufacturing process, to sourcing of raw materials. Maybe specifically for this window, there would be a reason to make such calculations considered by default. So that means that every project would be asked to show what they do under this category. And to go even deeper into the methodology, and I realize that it is quite a deep dive, are there any elements of this GHG calculation which could have default values? To give you example from another field, when we look about electrolyzers, maybe number of operating hours, capacity factor could be established by default. Now, relevant cost calculation. Here again, we can later, we have backup slides, we can explain what it is about, but in a nutshell, it shows what cost will have given, what cost will be this product will have compared, and they can be compared to fossil fuel comparator. Now, here the difficulty is that if we compare to the equivalent project, this project must be known. So are there products already available on the market? Are they commoditized? Or on the contrary, we don't have a knowledge of products to which product which will be manufactured by the project. We don't have knowledge about them. So question is, do we have a comparator, or on the contrary, that would be too difficult? Next question to this, what are the financial risks typical for this sector, how they can be evaluated, all these elements which projects have to show when they are assessed under the project maturity criterion. And finally, I am on the knowledge sharing requirements. So here we are asking what are technical, economic, project management, and any other items that you think would be useful to share so that technology develops faster, so that other players in the sector can learn from this project. What could be done to advance regulatory environment? So all which helps not only this, well, all that we can learn from this specific project, so that it is, so to say, easier for other projects from the same field. And of course, we know that for this to be shared, it cannot compromise IP rights. It cannot compromise the first mover advantage. Do you think about specific activities or tools which would be put in place to facilitate it? So here, I think I finished talking through the questions. Remember that there will be a time for proper discussion on this at the end of the workshop, and that we very much welcome written input. Thank you very much.
Thank you to both. I hope you can still hear me and see me. We just went a little bit over time, but that was really interesting information, especially that workshop about Horizon Europe and innovation funds, and separate workshops for lessons learned. Send us an email at the HPA and we will make that happen. It's the turn of my colleague Josephine. So Josephine, would you like to share the screen, or would you like Irene to do it for you?
I can do it. I will just... Voila. Let me know if you can see it.
Yep, but it's not.
Okay, I will go in presentation mode, yes. Yes, you can see full screen?
Yes.
Okay, thank you very much. Okay, thank you, Maria and Evelina, for this deep dive into the Innovation Fund. So I'm going to zoom out a bit more. So I'm Josephine van Beeselare. I'm head of EU Affairs at EHPA, and I will shed a bit more light on how heat pumps are now taken up into this REPowerEU, the REPowerEU document. Yeah, the reason why we are all here, it was mentioned by Maria and Evelina before. So as you can see from the REPowerEU main slide or main document by the Commission, it's really heat pumps are really put in the front, and it's like, I think, one of the first times that we have been put really as a picture on the front of such an important communication. So that is great news. I will go a bit quick because indeed we are a bit over time. So I'll just go through the main aspects. So this one has already been shown before. So the REPowerEU document, it's a reaction to the crisis in Ukraine and Russia, and to wean off the EU from fossil fuels in general. So there's many documents involved in the REPowerEU. The ones in yellow are those that mention something about heat pumps, and those with an arrow are those that really focus mostly on heat pumps. So first of all, in this document, in the REPowerEU, there's clear targets for heat pumps. So the EU aims at doubling the current deployment rate of individual heat pumps, aiming at 10 million heat pumps over the next 5 years. So this is actually only about hydronic heat pumps, even though this is not mentioned in the document. The Commission's REPowerEU document only talks about hydronic heat pumps. But if we look at the market figures, we see that this is only half of the heat pumps market at the moment. So we need to extrapolate this to all heat pumps, because also air-to-air heat pumps help to replace fossil fuels, for example, in supermarkets, in office buildings, and so on. So if we extrapolate this ends up in about 20 million heat pumps by 2027 and 60 million by 2030. Moving to the next slide. So how are heat pumps, what are the different measures on heat pumps really included in this REPowerEU communication and the EU Safe Energy Communication, two specific documents from the whole REPowerEU package. So in this presentation, these are organized by level of action. So because in the documents, it's sometimes said that the Commission will do certain things. For other things, they ask the co-legislators to take action. And for other measures, they really ask member states to take action. So that's how these things are organized. So first of all, what will the Commission do on heat pumps? So I will not go through all the details, but just the main things. So one of the main actions they will take is that they will revise the eco-design and energy labeling requirements for heat pumps, implying then that 2029 would be an end date for standalone fossil fuel boilers being placed on the market. So this will have a big impact on the heat pump sector. And then also the Commission has proposed a higher target for renewable energy and for energy efficiency, which are negotiated at the moment between the co-legislators. Then also very important, the first one, the reason why we are here indeed, is that this innovation fund, there's a double available funding for the 2022 call, and there will be this specific REPowerEU window, which Evelina and Maria have informed you about. Then there will also be support for R&D through Horizon Europe. The Commission will support efforts from member states to pool public resources via potential important projects of common European interest focused on breakthrough technologies and innovations. So this is also applying to heat pumps. Then the Commission wants to ramp up production of heat pump equipment through facilitated access to finance. And there is the Recovery and Resilience Fund chapter. So in the Recovery and Resilience plans, member states need to add a specific window on REPowerEU. If we then look at what is asked in the REPowerEU documents from the member states, well, first of all, the Commission asked the member states to focus more on the integration of large-scale heat pumps. Secondly, to speed up transposition of the Electricity Directive on active participation, which will be very important to reap the benefits of flexibility from heat pumps. And then a big chunk is actually that member states are asked to make full use of supporting and pricing measures for heat pumps. For example, reducing VAT rates for efficient heating systems, encouraging pricing to switch to heat pumps, removing preferential treatments of fossil fuels, also bonus grants to replace fossil fuels-based boilers, and, for example, also activate financing and fiscal incentives for fast-tracked heat pumps rollout. So all of these measures are asked from the Commission to the member states. Then the member states also have to report on a number of things. So they have to update their national energy and climate plans. They also have to add the specific chapter to the recovery and resilience plans. And one of the ways they can update this, or they can include what they can include in these plans is, for example, have renovation schemes and technologies increasing the energy efficiency of buildings, such as heat pump rollout. So these can be specific measures that can be added to the plans. Then the Commission also asks the co-legislators to do a number of things to incentivize and stimulate heat pumps. For example, to strengthen the ongoing co-decision on the EED. One of the measures there is that they ask the co-legislators to stop fossil fuel subsidies, so to put that into the EED. Another one is also to strengthen the ongoing co-decision on the EPPD, and there as well, the co-legislators are asked to put in the EPPD a phase out, to ask member states to phase out subsidies for fossil fuel-based boilers in buildings and to redirect these to subsidize heat pumps. Also other things, for example, to introduce national bans for boilers based on fossil fuels. So these are all asked to the co-legislators. And then stakeholders are also asked to establish a large-scale skills partnership under the Pact for Skills. So this is also very important, of course, because if you have enough production and you have enough demand, you still need the installers to install the heat pumps. So that's absolutely key. So now I went through the main measures that are put into the REPowerEU document, but at large at EHPA, we think to reach these ambitious targets, there's really 5 points to make it happen. And we see what is really needed is this heat pump accelerator, because now at the moment, all these measures that I just mentioned are spread out throughout the different documents. There's no clear one document, one strategy, one accelerator that puts everything together, and that also brings all stakeholders together and see what is concretely needed, by when, by who, and so on. So this is something we think is absolutely crucial, and this should look at 5 elements. First of all, creating trust in long-term ambition. What do we mean by that? Well, we mean that policymakers say that heat pumps, they are there for the long term. This ambition, they will keep having this ambition. It's no longer technology neutrality, but rather technology clarity, so that they are very clear about heat pumps, that these are the future for heating decarbonization. Then clean heating should be economically the most attractive one. Well, there are measures where member states are asked to look at pricing, but also at EU level, we need to keep looking at the pricing. So, for example, carbon pricing. Also, disruption should be avoided through legislation. What does that mean? Well, that also all legislation that covers heat pumps should be directed at achieving these ambitious targets. So, for example, very concretely speaking, there's a proposal on the F-gas regulation. This should be made, this should be adapted. So it's really also going towards this large-scale heat pump deployment as proposed in the REPowerEU. Then fourthly, this focus on skills. So there is this initiative to ask stakeholders to look into this large-scale skills partnership. Well, skills are absolutely key. I mentioned it already. You can have production, you can have demand, but you need the installers to put it into practice. And then lastly, of course, R&D is key. And also there, the Innovation Fund will help to bring this research and development to the market, to the test phase. And of course, the upgrade of electric grids is something that we for sure need to keep in mind at all times as well. So if you want any further information on this, don't hesitate to contact me or to contact our policy@ehpa.org email address. Thank you very much.
Thank you, Josephine. I was missing that slide with the smiley faces. I was just waiting for that one. Thank you so much. Now introducing Sanjeev Kumar. And you will have to share the screen as well.
Yes, I will do so now. Firstly, thank you, Dan, and to Josephine for fantastic groundwork, and to the rest of our speakers. I will just briefly introduce myself and then walk you through some of the perspectives from the geothermal sector. I'm Sanjeev Kumar. I'm the head of policy at EGEC, the European Geothermal Energy Council. And we have some kind of general observations. Within our membership, we have been a lot more consistent in the first and second calls, but I think it's important to just kind of remind everybody the full breadth of the heat pump space. When we refer to, especially to our colleagues in DG Klima, it's important to recognise that when we refer to heat pumps, we refer to kind of ambient, but also geothermal, so ground source systems, which you can see on your bottom left. You can have all sorts of sizes of geothermal, from small, like 25 kilowatts, up to 100 plus. You can have much more larger systems for industrial applications and for district heating and cooling, as well as power generation. The key thing is with geothermal that we're talking about base load energy, which is applicable all over Europe. I'm not going to go through this slide for the interest of time, but you've got some ideas of the kind of the depth. The key thing to focus on is the International Energy Agency's assessment of the levelized cost of heating for consumers in a few select member states. And what they found is that here, ground source heat pumps, geothermal heat pumps, were one of the most efficient and most cost effective over the long term compared to fossils, but also some other renewables as well. So it's important to understand that not only is the technology here, it's available, but there are key bits of innovation or key parts where the Innovation Fund can help accelerate their deployment. So sorry, apologies for the coughing. Firstly, some general feedback on the past calls and some of the concerns that our members have raised to us when we consulted them. The first thing to recognise is that, as I mentioned before, there have been many applications from the geothermal community over the last couple of calls, and we're disappointed that we haven't had a high success rate in projects actually being granted funding from the Innovation Fund, and that's largely because there are structural issues with the awarding criteria, which in some cases penalised geothermal, other renewables such as oceans, and we kind of need to find a way to rectify them. They are the difference between how quickly we can allocate the funding, but also how importantly, kind of Maria mentioned, the need for urgency, but we also need to target the funding of these calls so that we're actually solving the specific problems of that we have with the invasion of Ukraine and the crisis that's ensuing. Another issue is the kind of this weighting criteria around the cost efficiency of the grant. This is one of the questions that our colleagues in the Commission raised earlier, and the kind of general perception seems to be from geothermal, but also other parts of the renewable community, that this tends to favour mega large projects, mainly CCA. Air CCUS electrolyzers, and it's kind of actively discriminating against projects where the Innovation Fund's contribution would actually be truly additional. And this is something that we need to rectify in order to kind of unleash the full potential from our heat pump space. Secondly, there needs to be a better prioritization of kind of first of kind total solutions. So where you have a technology with a proven concept, then it should be given a greater priority than, say, for example, just one aspect of the manufacturing process or a component in the manufacturing process. It's important that we look at the technology overall rather than the one or two widgets, because one or two widgets, if they're not applied to a proven technology, are just simply not going to help us address and meet the targets of the REPower Europe. Another important factor is thinking around clawbacks. So the Innovation Fund is supposed to be result orientated. The pressure on results now is much greater than it's ever been before, and therefore, if projects have failed, then and depending on the reasons for the failure, but there must be some way in which we can claw back that funding to then reallocate to other projects who were perhaps scored very highly in the funding round, but weren't able to benefit from any funding. And the other issue is kind of project maturity. Now, in the context of geothermal, much of the work actually happens, or much of the magic happens below ground, below the subsurface. So it's important that the subsurface is kind of included when we look at project maturity. And then finally, the kind of the funding scope. Part of when you come to large scale capital intensive projects, and that's including the kind of production facilities or component factories, then you do have a risk element within those, and ways in which you can address, in the case of geothermal, geological risk. It's a similar type of risk profile for other renewable solutions, and certainly for large scale heat pumps. Then there needs to be ways around this one, and I'm going to come on to some suggestions that we have. This is my penultimate slide here, so I'm going to be very, very brief. So what are some of the recommendations that we have when it comes to the award criteria and how we kind of make sure that the Innovation Fund is successful, not in getting loads and loads of applications, but actually in funding key parts of the industrial footprint that we need in Europe so that we deliver? The first one is this notion of a medium-sized project call is quite important. Now, our speakers from the Commission earlier said that generally anything over 7.5 million is classified as a large project. What we really need to do is to flesh that out in a bit more detail, because what we see is mega large projects are the ones which are capturing all the funding. You only have to look at the last call to realise that there was no renewable energy project that was funded. Everything went to some form of fossil, more efficient fossil utilisation, rather than actually an innovative renewable energy. So within that call, something where you have a 7.5 million, 50 million, and then a 50 beyond 50 million will allow us to at least ensure that for the kind of categories that we're looking at in the context of geothermal, other renewables as well, that we actually have a genuine opportunity to capture your innovation funding finance to allow our projects to develop. We talked about the need to be specific to the kind of crisis that we have, and as we're all aware, the Ukraine crisis, and the reason why it's so important to get investments into the ground today is because we have a heat crisis, not a power crisis, and therefore what we need to do is to ensure that there's some form of dedicated funding called specifically for energy intensive industry, which uses low to medium temperature ranges, the kind of ranges where large scale geothermal and ambient heat pumps are really targeted to solving. We need to support our industry through these difficult times, and this is really where the Innovation Fund will be the difference between success and support for industry and putting our industry at serious competitive risk. The Renewable Energy Directive itself, the recital 26, shows that almost half of the industrial base, which is covered by the European Emissions Trading Scheme, the source of funding for the Innovation Fund, is actually governed by low to medium temperature ranges. So not only would we be cost effective, but we would ensure that we have a manufacturing base and an industrial base in Europe, and that's really a vital thing that we need to find a way to ensure that we safeguard this. We give our industry a chance to be competitive in the future. The second thing following on from this is that in the past, what we found is that power projects compared to heat projects have an inbuilt advantage because they're always replacing coal as the main fossil source, whereas in the context of heat-related projects, they're replacing gas. And of course, gas or fossil methane doesn't have the global warming potential of methane emissions in the short term included in its assessment number. And what we need to do is to add the global warming potential using the IPCC's latest data to ensure that at least we fairly account for the replacement of fossil methane in Innovation Fund projects. And then finally, going back to the crucial issue of de-risking projects, be both for the manufacturing equipment, but also for project development. We have to be smart about how we allow the Innovation Fund to de-risk some of the, in the case of geothermal, the geological risk, in the case of oceans, resource risk, same for solar thermal as well. We have to be very, very specific. Now, one of the solutions that the industry is recommending is that we have a milestone-based approach to distributing the funding, so that some of the upfront costs and the upfront risks that go with those costs are covered earlier than later. This allows geothermal projects to have much more of an impact in the overall Innovation Fund. So let me conclude by saying two things. Firstly, the Innovation Fund should be making a considerably bigger impact than it's having, but what we need to do is to move away from the kind of the old-fashioned rhetoric of the valley of death towards better targeted support. We have to make sure that all the support that we are targeting is to the sectors that desperately need them. And on that point, I'll stop there. Thank you very much. Over to you, Dan.
Thank you so much, Sanjeev. Lovely to have you here, as usual. And thank you for the presentation. I like that quote with the magic happening underneath the ground. So my colleague Irene will now try to reshare the screen in a traditional or non-traditional way. Let's see if it works. In the meantime, it is my pleasure to make the introduction of Thomas Novak, our Secretary General, who is a long-term renewable energy aficionado. Apart from closely following the energy transition, both in the electricity and heating sectors, he is the owner of a heat pump, a PV power plant, and a building in which both collaborate peacefully. Now, from very confidential information, I know that he is also driving a car with a heat pump on it, and you can probably know which one it is because it has a sticker saying Heat Pump Forum on it. So, with that being said, Thomas, the floor, virtual microphone, virtual camera is yours. Please.
Thank you very much. Thank you, Dan. Thank you, Evelina, for the introduction. Maria, also Sanjeev. That was all very interesting, and I think a lot. So some stuff to digest, and I hope that we can get a bit more light now in discussing what really is necessary, in discussing which key developments we see in reality outside of support for large heat pumps, which challenges do we face, which opportunities do we see in relation to innovation and investments. And obviously that should give you some insight and input to how to shape the funding in the future. I am here with 5 distinguished experts from the large heat pump field. Some of them also represent companies that do smaller heat pumps, but let's really focus on the high capacity, high temperature level heat pumps today. I want to start by introducing José La Loggia. He's the president of the commercial HVAC system in EMEA of Trane Technologies. He has a long history of achievements on his level, so I will not introduce all of them, but he's a good speaker and really happy to have him here. Likewise, Drew Turner from Danfoss. He's a director of global sector integration, a topic that is really interesting because we want to push for a joint development of the vectors electricity, heating and cooling. And heating and cooling integration is also something I have been discussing with Jose many times. We have to stop thinking in only one service provision. We have to look into providing and using heating and cooling as much as possible. Then there is Patrick Crombez. He's the general manager of Daikin Europe. He's also a member of our board and really a long-standing supporter of both heat pumps and the European Heat Pump Association. Let me say that all the speakers are also members in the association, so thank you for your help there. Very happy to have Alix Chambry here, who is also really a long-term heat pump supporter in the past with Danfoss, now global VP Global Public Affairs with Viessmann, and you have all seen that Viessmann has announced recently a very big investment. So there is money flowing into this directive. Let me also say that other companies are investing and have not announced it so prominently. There is several hundred millions of euros that are currently invested into the sector. And last but not least, Marco Baresi, Institutional Affairs Director and Marketing Director for Turboden. Turboden has been acquired by Mitsubishi Heavy Industries. Is that noteworthy? Yes, it is, because we do see an acquisition stream taking place. And that is maybe at an interim stopping point, but it has happened over the past. So Jose, Drew, Patrick, Alix, and Marco, I'm very happy to have you here and to share some questions with you. We have debated and prepared a little bit how we want to unroll this discussion, and I would like to open the floor by asking all of you for quick introduction statements based on the REPowerEU communication. This was communicated, announced as a package in the beginning, as a communication in the beginning. Now it has become a package, and as Josephine has said, it addresses first and foremost hydronic heat pumps. It says that we should double sales and that we should achieve something like 30 million hydronic heat pumps by 2030. From your individual perspectives, is the industry ready to achieve this target? Are we ready to really fulfill that ambitious target? And if you're more skeptical, what is the biggest challenge that you see that needs to be overcome? And maybe if you can make a point towards funding, is funding one of these challenges that we have to look into? So maybe we just start around in the order of the pictures here. So Jose, I would ask you to comment first.
Okay, thank you, Thomas. So from my point of view, I think the goal is very much achievable. The only thing that I try to talk about, and I'll talk a little bit about it later as well, is that we have to be careful that we don't sort of throw everything into the same bucket. So when we talk, and that's why I'm very happy that, you know, the title of this call around large-scale heat pumps. When we talk about large-scale commercial use heating, whether it's process heating or comfort heating, or, you know, potable hot water or domestic hot water production, I think the barriers or the hurdle rates to decarbonize that space are much, much lower than in the residential space. And the reason I say that, and it goes to what you just mentioned before, Thomas, is that we need to look at heating in this commercial space and industrial space as combining cooling and heating. So what does that mean? That means that in the majority of times, if you look at any commercial building or any industrial process, there's a chiller plant and a boiler plant, and those two plants are working in silos. Now, if you can convert with technology the chiller plant to a plant that can create heat and cold, then you no longer need the boiler plant. And then all these arguments that there's not enough industrial capacity or there's not enough installers, there's not enough, you know, people who know how to, you know, about heat pumps sort of go out the window, in my opinion, because basically anybody who is making chillers today already has the capability of making machines that can make hot and cold water. They can sell those machines through the same channels. They can service those machines through the same channels. And it makes the adoption very fast. So I think it's very important that we really segment this away to try to go for the low-hanging fruit, which is in the commercial and industrial space. around combining heating and cooling and breaking these silos that exist from a historical point of view. So this is what we're trying to do with our company, and I have a presentation later that will talk a little bit more detail about some of the success that we're having in that space. But I think if we all really start to speak that in this arena, the limitation is just really awareness and educating our customers, then the thing can accelerate really, really fast. I'm not negating that, on the resi side, residential side, there's a lot of work to do. The technology change is quite heavy because a lot of houses don't even have cooling, and you need to do a lot of things. But let's get the low-hanging fruit first, right? And then deal with the more problematic areas second, let's say, or in parallel.
So you're basically saying that if we combine the services of heating and cooling, then we can double capacity, and that is actually then overcoming quite a few challenges. Then let's hope that this is recognized also on the Commission side, because in the legislative framework is not yet the dominant focus of the different pieces governing our sector. Drew, you are, I introduced you as the director for sector integration. Do you see a similar benefit also for the integration of heating, cooling, and electrification?
Absolutely. Yeah, the quick answer is yes. First of all, good morning from Toronto, from the ASHRAE conference. The opportunity is definitely for the integration of cooling and heating systems. That's why our organization exists. That's what a sector integration is, at least from our context, right, is primarily an opportunity to integrate the heating and cooling sectors by taking advantage of the heat recovered from cooling for heating and breaking down that silo that Jose put so eloquently. So then the added opportunity and complication with that is, if you're going to do that, you either have to build in significant storage, or you have to go larger scale so that you have the scale built-in storage with it. And how you go larger scale is, of course, with the district energy system. That allows also eliminating the disconnect between supply and demand that comes from the integration of additional renewables, which drives the whole opportunity for the electrification of heating in the first place. But then the complication becomes, and this is to answer your question, the industry itself is ready, but is the infrastructure ready? And from the Danfoss viewpoint, it really isn't, because you don't have the infrastructure where you need it to take full advantage of the biggest opportunity for retrofit of cooling systems to provide heating to district energy system on critical facilities, which is by far the best opportunity, is what we've discovered. You don't have that infrastructure outside of certain locations. Primarily there in Europe is where it exists, but only in certain countries and certain regions. And there is funding going on to and legislation happening to break down those barriers, to eliminate the lack of infrastructure, but there's a lot more work that needs to be done to do it. And that's the primary issue that we see going forward. Is it's not only about our industry, but it's the related industries and making sure that we have the infrastructure necessary to enable the integration of the cooling and heating systems at large scale.
Well, super. I think I see here also that there is a lot of additional work. So I hope Evangelina and Maria are taking good note of this, that we need an integrated research design that is not only looking at the product itself, but also at the system both ways, both for heating and cooling and for electricity and heating cooling. Patrick, your perspective on this. Are we ready? And what is the biggest challenge that you can see? I think you're still muted. Maybe you want to unmute yourself.
Okay, sorry
Thank
for
you.
that.
Now it works.
Thank you for having me. And yes, indeed, I would like to join the comments of the first two speakers, that purely from an industrial point of view, manufacturing point of view, we are ready. And I think most of the companies present here have already started building up capacity, which is, I think, possibly the number one thing to look at, especially if you look at the smaller end of the application in the residential side. On larger capacities, and we've been involved in this market for the last 25, 30 years, and indeed that was said before by the speakers as well. The integration between cooling and heating is a very easy way to also make it economically viable for most of the customers. So I think on that side, definitely in commercial applications, we've seen a move towards decarbonization much more faster than in the residential side, where, because indeed there, economically speaking, it just works out. I think this challenge still is coming now to the residential market, but I believe we can solve that one, then the market will also pick it up. We've seen that before, and there's no real reason why that wouldn't go on from now. From our side, as manufacturers, I think it's our duty to indeed make sure that the manufacturing capacity is there, and I think the recent announcements on REPowerEU, I think have given everybody now really the confidence to start the investments and to speed up the investments to be able to meet the challenge ahead. So I'm quite confident, looking forward to the rollout that we see happening now. The ramp up is going extremely fast. So it's challenging times, but it's extremely interesting and rewarding.
Thank you very much, Patrick. I think Alex, speaking on behalf of Viessmann, you have been in the press nationally, internationally on taking that plunge and building on the confidence a huge investment program. Maybe I can add one point to you. How are you? Do you think is the value chain ready to accommodate for this amount of money that you want to invest? And do you have enough technical people that help you execute this investment?
Yes, thank you, Thomas. Indeed, so we announced that we want to invest 1 billion euros in clean tech and mainly heat pumps, but also other clean technologies like district energy and other solutions. Are we ready, Thomas? I would say yes and no. Yes, we are ready to take on the challenge and to invest massively and make what we call right climate history. However, I want to raise the bell. We need definitely funding. And why that? Because we are operating in unprecedented turmoil. And I want to emphasize that again. We see rising material price, decreasing consumer confidence, a possible recession as soon as next year. We see in unprecedented disruptions in the supply chain. We have to send back home our blue sellers every week because of lack of supply. So again, yes, we are ready. We want to. Now, whether we can deliver a doubling already next year or in 2023, as the German government wants, I would say not everything is in our hands, because there are external disruptions that we do not control. So we want to, we are ready to invest. Now we need policy support. We need funding to make this acceleration, this incredible industrialization of the heat pump ramp up in unprecedented time. And I want to highlight that in the automotive sector is given minimum 13 years to make the transformation. In the heat pump sector, we are given around 2 years. So yes, we can, but with significant support. If we don't get that policy support from the funding side and the policy side, we risk ending with a massive acceleration of the import of space heating into Europe. And we see the figures of the trade balance in space heating is worsening in Europe. We used to have less than 10% import of heat pumps, of space heater in general. These figures is worsening. If we don't get the support, including by the Innovation Fund, we risk creating another dependency towards, non-EU manufacturer. So that's a very important point I wanted to highlight. So funding absolutely needed in terms of grants, as highlighted by DG Klima. Another thing which I want to say, are we ready? I think yes, we are. And we do need the proper legal framework, because we keep hearing from the industry or for some players that yes, we can, ramp up heat pump, but only if there is no legislation. And there we raise the counter alarm. Why? Because if we found billion of investment into the heat pump ramp up, for example, using a refrigerant like HFO, we risk ending with a sunk cost. Why? Because after a few years, HFO will be most certainly forbidden, if not at the EU level, at the national level. And then you have a scattered EU market, you risk having sunk costs. So for us, we say, yes, we can, securing that those investments we make allow us to do a leapfrog into sustainable heat pump. If we all invest billions of euros, let's make sure we invest them immediately to the more sustainable heat pumps and not those heat pumps that actually worsen the global warming or the environment.
All right, thanks a lot. You put the stick into the bee's nest immediately. I think maybe we can push the refrigerant aspect a little bit to the side, because that will derail the whole discussion. We are discussing it also inside this association. We are discussing it in a special working group. We are discussing it with you, with others. But let's look at the investment first. And I've taken the point that, yes, let's leapfrog. Let's not make a mistake. That's your point. I think especially when we discuss about large heat pumps, the answer is not so easy. I guess that Jose would want to comment on that. But if you do, please keep it short. I want to give the floor first to Marco, because I think there is an interesting aspect in Marco's company. Turboden is not originally a heat pump manufacturer, and I think it's important to see that we also need to shift whole industries that come from the fossil area into a heat pump based solution world. So Marco, how do you see the situation? Are we ready? And what can we learn maybe from your past, where you built ORC turbines that were built mainly on fossils?
Yes, thank you. First of all, I fully agree with Alex, so that is the point of view of a EU manufacturer. So as you told, we are manufacturer of ORC, so we are manufacturer of turbines mainly for renewables, so geothermal, waste heat recovery and biomass. And we decided to shift to heat pump in order to enlarge our portfolio of solutions for energy efficiency. But giving a reply to your question, in my opinion, is not only a question related if we are ready for manufacture this plant, but it is a need, because as I told a few days ago during an industrial forum in the European Commission, we need to increase massively the volume, because higher the volume, lower the cost. And in principle, Turboden is focused on two main areas. The first one is large heat pump, low temperature large heat pump for district heating. Are commercial available, few but commercial available. So we need additional effort in order to increase the volume, but also in order to increase performance, reduce cost, also with working fluid, different working fluid, and so on. In other words, we need innovation. But we are also focused on high temperature industrial heat pump, large scale industrial heat pump for industrial processes. And are simply not massively available yet. So we need effort in development, and we need the demo plants in order to increase the volume. Nothing else to add for this session. We have done a lot of work with geothermal, ETIP, European Technology Innovation Platform, and I know that Philippe will also address the specific needs of the industrial side for the geothermal needs, the results of this working group.
I think there's going to be quite a few very interesting presentations later on good projects where we can see what is currently possible and where we stand and where we might want to have more support and where we might want to require more support. As a second question, I wanted to point to the fact that was mentioned 2 or 3 times, the 10 million, 30 million or doubling of heat pump deployment is currently based on hydronic heat pumps. And since especially in large applications, we also see quite a lot of air-based heat distribution, do you think this is something that that is limiting the potential? And I would, versus the Commission, DG Klima, especially also ask you, do you think that, or would you agree that we should ask DG Klima not to take that limitation on board? And maybe you can just raise your hand when you want to comment on it. And I see Alex immediately smiling and shaking her head. So then Patrick next. We have actually a very nice way of doing it here in the people's list. So we see who has raised their hand first. But Alex first, and then Patrick, and then Marco, and then we continue. And also, if there's anybody in the audience that wants to ask a question, please type it in the chat, and we see how much we can take on board. Alex, please.
Thank you, Thomas. So we think we should be clear on the distinctions. There are three distinctions to make, right? There is process heat, that's one topic, and then there is space heating. And for space heating, we think we need to make a very clear distinction between hydronic heat pumps and reversible air-co. And for us, reversible air-co is not to be mixed with heat pumps. Why? Because first, they are regulated in different frameworks. Under eco-design, you have lot 1 and 2, which is the scope that we favor for hydronic heat pumps. And you have lot 10 for air-co. And what we say is today, for residential space heating or commercial space heating, the most important issue is to ramp down the consumption of gas. We want to reduce gas demand. And in those buildings where you have gas boilers, it is always hydronic. You always have the radiators and the water pipes to heat the building. So if you do want to reduce gas demand, the only intuitive solution is a hydronic heat pump. Gas boiler out, hydronic heat pump in, and it's feasible now. We have the technology with a high temperature heat pump, as you know, especially with natural refrigerants. So it's feasible. So we say, if we want to track our objective, meet, the REPowerEU objective to phase out gas by Russian gas, by 2027, the absolute priority is hydronic heat pumps, especially for space heating. And we strongly recommend to use the existing definition of which is in the scope of lot 1 and 2 eco-design for space heaters.
But we need to take into consideration that there's also commercial buildings that are mainly heated by air, right? I think Patrick can really talk about that. So yeah. We have to have the whole picture in mind. Patrick.
Yeah, I agree with that one, Thomas. I think on the one hand side, Alex is correct in saying that the current day regulations are different, and we probably want to keep them also that way to keep the clarity. But from an application point of view, it's absolutely clear that air-to-air heating systems are being used in vast majority of offices, hotels, and whatever today. So they do have a part, and I think towards the future that will continue, as also fresh air requirements are ever increasing. So that will give it more possibilities to integrate even beyond just pure heating and cooling, but also integrating then fresh air requirements. Another point is towards residential, and there on the one hand side, you could say that reduced gas consumption now and an air-to-air heating system could actually contribute to that, and is in certain parts of Europe actually heavily contributing to that if you go to the south. Where most of the AC systems that are being installed are reversible, and nowadays more than ever are being used also as a heating device. But more important also towards the future, I think it's as buildings, especially new builds, are getting more and more efficient, heat loads are more and more reducing, to some extent cooling loads are even increasing, then I think you can see buildings going up in the future that will have sufficient requirements on cooling and heating to work with an air-to-air system instead of in new builds having hydronic heating still. So definitely towards passive housing, I think this is a direction that we will see happening as the loads are changing. Yeah.
Thank you very much. And then we haven't even discussed exhaust air heat pumps and sanitary hot water units. So there is actually quite a lot to be defined a bit more clearly than what we have read in the current communication and package. But Jose, you wanted to come in.
Yeah, I agree with what Alex said, and also Patrick. I just want to make it clear, like, you know, it's not a question of being reversible or not. There's a lot of rooftop units which, you know, do cooling in the summer, but for heating they have gas furnaces inside them, right? Especially in Eastern Europe, in Northern Europe, and all of those technologies could be replaced with a heat pump rooftops, a like-for-like change. And the good thing is that rooftops units usually have a much shorter lifespan, so we should be replacing those units with heat pump units. So excluding them is unusual for me, right? Because I think it's a very low-hanging fruit as well. In addition, a lot of air-to-air systems use electric heat, which, whilst probably better than fossil fuel-based heat, is very inefficient, right? You get a COP of 1 or slightly less than 1 when you could be at the 3 or so with a heat pump. So for sure, there's, from an energy use point of view, energy efficiency point of view, but and from electric heat, replacing electric heat, and then from a gas reduction point of view, the air-to-air makes a lot of sense to include it.
Yeah, very much so. I don't see any further hands here. What I would conclude from this round is that we need to look into the different application areas, and there are differences, especially when it comes to support also, both on the application area and the capacity, but also on the regional distribution. When we consider the Nordics, which have a lot of air-to-air heat pumps, where actually they are not reversible air cons, they are really heat pumps that are used for heating and can be used for cooling, and the design is different. And also the Mediterranean has that. But I guess I saw quite a bit of agreement among all of you. Then I wanted to touch upon the aspect of innovation and the differentiation between what is a single off product, like a true not market ready innovation, and whereas the replication potential. Jose, Marco, and Drew, specifically to you, but the others are invited to come in. You will present innovative projects later, and my question to you is: do you think that these projects that you're presenting, are they innovative in a singularity perspective, so they are one of a kind, or have you thought about multiplication potential beyond the example that is shown here already now?
Yeah, I'll start here. What I'm going to present, I like, we need to look at things at a system level. I think Drew spoke a lot about that in his introduction, but just looking at things at a product level, I think is a bit limiting, because you at a product level, you can get incremental improvements in efficiency. If you start looking at a system level and you're breaking down silos, then you can make, let's say, exponential jumps in efficiency.
Yeah, just to pile on to that, the opportunity is definitely much more at the system level as far as innovation. We don't need to innovate from a heat pump's perspective. You know, every chiller is a heat pump and every heat pump's a chiller. The first innovation is just making sure that the market recognizes that and transitions from a solution focus of separate cooling and heating systems to integrated cooling and heating systems with a, you know, for example, formerly water-cooled chiller going to a water-to-water heat pump system-based design. That is the innovation, is the innovation mindset, if you will. And then once you recognize that, the system level opportunities are exponential. But everyone, the second part of your question, everyone is custom. You know, there is no replication. There is replication of concepts within those system innovations, but every application, in my experience on the 116 projects, sector integration projects that we worked on so far in the last year or so, have been on, everyone is custom. And so that's where the real innovation comes in, is taking the specifics of every application and discovering what are the opportunities for optimization of both the cooling performance as well as the heating performance, and then the integration of those systems is the opportunity.
Thank you, Drew. Marco?
Yes. Yes, I agree. We have a big opportunity at system level, because when we develop technology, we can apply, and I'm thinking about the situation of Turboden, we can apply, for example, for geothermal, but at the same level, we can apply for example, industrial project. There are different projects from steel to cement to glass, and also for other applications. So there is a huge opportunity for this implementation. But we have two different goals with at this time. One is short term, and the other medium long term. And in my opinion, we have to take into consideration that. Second point is related to the innovation fund. If I'm not wrong, most of the money comes from CO2, from industrial processes. So in my opinion, it's correct to address the innovation fund to the industry and to the energy efficiency also for industrial level. Mainly in order to make this sector more competitive. And at the same level, as I told you, if you develop technologies for large scale, industrial level, you can apply for geothermal, for large scale, and so on. Thank you.
Very good. Thanks a lot. We have a few questions in the panel here, in the chat box here. I wanted to ask anyway something about the refrigerant discussion that is ongoing. So let me rephrase it slightly. What I was wanting to know from you, where you see the refrigerants availability in capacities over 100 degrees centigrade and big heat pumps, because there's a huge discussion on smaller heat pumps, but there's also a separate segment that addresses 100 to 200 degrees centigrade and a couple of 100 kilowatts to megawatts. But there's also then related to it maybe a question here in the chat box that says, should we have specific requirements on the greenhouse gases in the innovation fund? And maybe can I ask you, do you think that focusing on the greenhouse gas emission of a refrigerant is the right focus, or should we rather take system efficiency and the system's perspective into consideration? And that's an open question to all of you, really.
Yeah, maybe I can start here. I think first of all, in terms of, let's say, high temperature heat pumps, you mentioned less than 200 degrees C there on your email. I think there are some very interesting refrigerants that are used in the cooling space today that could be used in the heating space, and we've done some analysis of that. We also sell some machines that way. So, for example, the HFO R1233ZD today is primarily used in low pressure centrifugal chillers, but this refrigerant could be applied and is applied by us on screw-based or medium pressure designs, and then you get very high water temperatures that which is then very scalable to the products we already have. The focus on GWP over refrigerant, I think it's correct. I think we should follow the F-gas regulations around that. I don't think the F-gas regulation is unreasonable in terms of reducing GWP. I think we should be careful that we deviate the F-gas regulation a lot from what is already planned in terms of a phase down, or to, let's say, a minimum of, say, whatever the requirements are there, 400 or 500 GWP. I think in a lot of applications the GWP will be zero. There'll be some applications where you need to have 400 or 500 side GWP, but in balance it's going to be much lower than before the F-gas regulation.
So you're basically reconfirming that we are in line with reducing the emissions, and that's
yes.
basically what we see every day. The yes. GWP values are reduced as we speak, right?
Yes.
Then we have Patrick, Alix, and Marco.
Yep. Yeah, I would agree with that. I think if you look over time, GWPs are decreasing. If you just look at products that are listed within KeyMark, the certification program, we see year on year products appearing with lower GWPs. So I think that tendency is definitely there, and again, that's our responsibility, I think, as manufacturers to contribute to that. The point is, and I think then especially looking towards bigger devices, higher temperatures, I think there really the application will determine what you will use, what you need to use to make the correct balance between efficiency, affordability, installation possibilities within the sites, etc., etc. That will drive ultimately the product and the solution that you will need to use. So I would really argue that to some extent a certain flexibility needs to be there in order not to I would just call it waste opportunities.
Thank you. Yeah, good point to take home. Then we have Alice, please.
Yes, thank you, Maria, for the question. I think GWP is not enough as a criteria to assess, the impact of a project and of the refrigerants, because with GWP, we will only assess the impact on global warming, and that's mainly an issue for HFCs, but you will not assess the PBT impact, the impact on the environment. And as you know, an alternative to HFCs, which can be used, but we do not favor it, but it's a possibility. It's a use of HFO, and HFO has zero global warming potential, but it has, it releases TFA when it's I don't know the word in English, decompose. So anyway, it has a persistent bioaccumulative and toxic impact on the environment. So when we consider the financing of innovation project and also for the ramp up of heat pumps, we need to consider both HFE's global warming potential and the impact on the environment, which is dealt under the REACH PFAS legislation. Okay. Now for the GWP and HFCs, with the industry, we agree that we are working on the release. Now it does need innovation and adaptation and a longer lead time to make a phase out, to reach a global warming potential at zero with a natural refrigerant. So we are working with EHP and EHI. We believe that we need a longer lead time than as currently proposed in the F-gas regulation, probably around 2030. So I would say today, when there is a call, a proposal for a heat pump project, excluding HFCs today in 2022 would not be realistic because industry needs time to prepare. But assessing the long-term viability of the project is a must. And of course, we believe not supporting anything relating to HFO because we believe in the midterm it's a sunk cost.
Okay, here I need to intervene on behalf of many other members because this is to be very clear. This is not an EHPA perspective as we speak. There is quite a distributed opinion inside this industry, and especially when it comes to temperature levels that are above 100 degrees. There is a few prototypes that
I did not say, sorry, Thomas. I was talking indeed about space heating. Thank you for the clarification. For process heat, we agree that for some application, it will not be possible to reach high temperature, as you say, for process heat without HFOs or blends. Indeed. So for process heat, we need to have a different approach. Absolutely agree with you.
And let me say also that nobody has an interest in polluting the environment. So all the time when we discuss about the use of these refrigerants, the first and foremost prerogative is a precondition is to have hermetically sealed systems to the maximum possible extent, especially when it comes to large heat pumps. This is often machine rooms anyways. So there is a capacity and a competence in handling also difficult materials that we wouldn't want to put into end user homes. Just to have that clear, and I think this can serve as the basis for further discussion that inevitably will have to happen, and hopefully also will trigger release of funds in the direction of moving us on a sustainable and future-orientated selection array of available substances. But we have Marco and Drew, and then I wanted to also discuss one of these questions in the public that asked for a specific call for, let's say, mid or low temperature from an overall perspective above 200 degrees centigrade projects. But first, please, Marco and Drew.
Yes, Thomas. As you said at the beginning, we are quite new as to Boden in the heat pump manufacture, but we are very experienced in the ORC technology. And we are experienced, ORC technology is a closed loop using different working fluids, low temperature, medium temperature, high temperature. Currently, we have experience with 10 different working fluids, depending on the source at the beginning. So GWP is a correct parameter, but it is not enough, as they told. We are, for example, using some HC because we need to be pragmatic. If we need to be very efficient in our manufacture, there are different range of working fluid depending on the temperature we need to reach. And so, in my opinion, this discussion could be open also for the application of this working fluid in order to maximize the efficiency. Higher the temperature, we need different working fluids in order to maximize efficiency.
Thank you very much. Drew, did you take your hand down or you still want to come in?
Yeah, as is usually the case, there was enough said on refrigerants, right? But I will add a couple comments but keep it short. One of the distinctions that GWP has to be in a part of it, but as everybody said, and just to pile on again, I think it's a much broader subject. And one of the added topics that needs to be a part of the evaluation is the average leakage rate of the solution that is applied. And more needs to be done, I think, as far as that goes. So, for example, right, your DX refrigeration system, no matter what refrigerant it's using, is going to be leaking on the average in somewhere in the range of 10% or so per year, whereas your packaged chiller or packaged heat pump solution on average is going to be less than 0.5% per year. And so, keeping that in mind, it all comes into play. The working fluid and the capability to achieve the temperatures, the associated efficiency of it at those temperatures, the GWP level of it as well, and then finally the solution that's applied as a part of it. All become critical factors. It starts to feel, to use in a very American term, it feels like a rope-a-dope when you go down the rat hole of refrigerants topics frequently. And that's what we really need to avoid, is to make sure that it doesn't become that rat hole of a single topic.
I totally agree, and I wanted to add on this that we have compared based on the PV factor, the emissions, and what comes out of that type of comparison, and that's quite accepted as a comparison method. Then you see that the emissions from the fuel that you use is much more influential than the emissions from the refrigerant. So maybe as a conclusion to this discussion, we can certainly say that if you cannot install the heat pump because of whatever requirements you have and you fall back on a fossil solution, then your emissions will be higher. So really we have to keep in mind, what do we want to achieve? Do we want to reduce meaningfully the CO2 emissions, or do we focus on a component of that challenge? So then I hope you allow me to say that we will take 5 more minutes on this last question, because this is on the Innovation Fund. So let's give one round of input to the speakers on, do we need a specific call? And that is also then maybe a bit of something to take home to the Commission. Do we need a specific call for heat pumps between 100 and 200 kilowatts, and what would be typical applications? Also keeping in mind that the International Energy Agency has proposed that we need 500 megawatts of newly installed heat pumps in this category, but from now on to 2050 every month. So good to keep that in mind. 500 megawatts every month. It's on a world level, but nonetheless, I dare to say that we are not ready for this. So any support that you can give would be very much appreciated. Anybody wants to go first on what do we need? Do we need that? Is that helpful? Any specific area that you would suggest to focus research and innovation activity on? So now I need flexible panelists. Where do you want the next call to be in?
Thomas, let me be speculative.
Yeah.
We need to do a specific call for large-scale industrial heat pump. So we are thinking in the range 3 to 30 megawatt and up. And we are focusing on this and also on high temperature heat pump.
Okay, can I just add one point to the consideration? Nobody has talked about new business models integrating flexibility. Is that something that we need? Should the Commission encourage us to also integrate flexible electricity prices into the development of solutions? And then I see Patrick and Alix have raised their hands, please.
Yeah, I would indeed go on this discussion about flexibility and smart grid readiness, and I think that's just as valid for small units as it is for larger units. I think the integration there of units and technology with the grid, definitely in larger, but again also in smaller units, can be a major benefit. So I think on that side, we've had a number of projects going on in the past couple of years, but they still haven't achieved a lot of traction. So I think that there's still quite a lot to be done there. So I would think that there is still some opportunity to work it there. Yeah.
Okay, then we have Alix as the last speaker.
Yes, so large-scale application, of course, yes, it's always useful. What I want to tell is, beside the large-scale application, the must-win battle is high temperature heat pump for the existing building stock, because new build is just 1% of the entire building market. If we want to achieve both a climate target and reduce the energy dependence on Russia, the #1 must-win battle in the next 3 years is a ramp-up of heat pump for residential space heating. And for that, the big topic is the high temperature heat pumps. What I often say is, for me, a successful call or heat pump ramp-up is one ramp-up that focuses on the 4 S: speed, scale, customer satisfaction, and sustainability. And I'm happy to, we have too little time for me to explain what is behind each S, but that's basically in the summary what we call for.
Thank you for being short, Alix, because I know you could probably have your own seminar on this. But really, we're coming to a close. I don't see any further mentioning from your side. If normally I would say, so what would you require? But I think we're already 10 minutes over time, so I keep that short. I see here, and that is one last thing that I wanted to just reflect with you. Alexander Korbachai from Johnson Controls says, we are ready to deliver, but the customers are not asking. Is that something that you see yourself? Do we have to push? And maybe this is really specifically for larger heat pumps. Do we have to push for the availability of industrial style solutions in the capacity range, in the temperature range that we have discussed? And should the Commission take this into consideration? Last round, please, just very quick statements on that. Is that realistic? Commission, should you take it into consideration? And here I see Jose first, and Alix has still her hand up.
I 100% agree with that statement from our friends there at JCI. We need to have more awareness in the market that we are ready to do this, and there is no limitation, at least in the commercial space. And that could be, maybe there should, I'll steal one of your famous quotes there, Thomas. Every time you see a chiller rejecting heat to the atmosphere, that is a thermal pollution, right? Why are we allowing thermal pollution to continue, right? Why don't we put some caps on that to push for people to ask the question, should I really reject this heat or should I reuse this heat when I've got a chiller and a boiler sometimes sitting next to each other? It's crazy.
That's true. Thank you, Jose, for reminding all of us of that. Alix.
Well, for industrial application, personally, I would say the demand is rather there. I mean, now with the war in Ukraine, the wake-up call, the alarm, the emergency has never been more vivid. And I can tell we have a subsidiary called Etanomics, who does just that, energy services, energy audit, and so on for industrial players. And their turnover is skyrocketing, and the demand for solution is skyrocketing. So I'm not worried at all on the demand side for industrial application, seeing at the figures. I'm more worried for the residential sector because a heat pump remains much more expensive than a gas boiler. So there we absolutely need stable subsidies to secure a stable demand in these crazy times.
Thank you very much. So I see no further hands raised. Then I would like to close this panel. I think we have seen very clearly that being smart about solutions, integrating heating and cooling, integrating heating and cooling and electricity would help us on the capacity side. So also to the Commission, having these sector bridging projects is something that would be helpful, not least also to reduce, Alex has mentioned it for residential, but to reduce also the cost. Because if we can use heating and cooling at the same time, the costs will inevitably be reduced. We have to look at the value chain. I think we didn't touch at all on the aspect of component supply. So yeah, is the component industry ready, and do they understand how much additional components we will have to ask in order to achieve this target? Maybe also the global value chain, did it receive a dent as the result of the war and the COVID pandemic? Will we need capacity on an industrial level in Europe for new component factories? And what about we certainly need a segmentation between the different application areas. We have seen it clearly. There is a different type of perspective when it comes to residential and renovation, small capacity industrial, high capacity industrial, and also high temperatures in industrial. And maybe we should not lose out of sight the importance of creating recognition in the public also as part of these projects. We are, as EHPA, doing often the dissemination part. I think it's an important point. And when I remember other discussions that we had, it was always said that we have to move from innovation research to deployment research. I think one of the things that became very clear in this 45, 50 minutes is that we are ready to do individual solutions, but now we need to multiply all this by 1,000 or even more. So please keep this in mind when writing the next calls. All of this that can be done on a single example is not as good as those things that can be done on 1,000 or 100,000 unit level. And with that, I thank you very much. I thought it was a very interesting discussion. Again, I learned quite a few things that I wasn't aware of, and I hand back to Dan.
Thank you, Thomas. Thank you, everyone. If only we could make the webinar more than 3.5 hours, but we are well aware that the workshop is a bit long this time. So why not take a break, rest the eyes, make some coffee, tea, whatever else, and stretch your legs, and 10 minutes break. Please, Irana, could you put the video for the break, and see you later for the project presentations.
Bye-bye.
And that is it. I hope you really enjoyed the break. I hope you enjoyed the small videos that we had. Very proud to be part of this project, and I wish we had a larger break, let's say, so we can put you all of our projects. It's just that we had to fit them in 10 minutes exactly. Without further ado, and hopefully you can still hear me and see me, and I'm not just talking to the computer. It's my pleasure to basically begin with the project presentations. And the first one to present will be Drew Turner. You just saw him at the last session. I'm going to ask Drew to just press the button called Take Control, and let's see if it works to change the slides. In the meantime, I'm just going to quickly introduce him. Drew Turner is currently Director of Danfoss Global Sector Integration, focused on the electrification of heating and heat pump systems in symbiosis heating and cooling applications. He has been in the HVAC industry for 25 years and with Danfoss for the last 8, holding a variety of roles over the career, including product support, marketing, planning, business development, market research. In addition to his current position, he is a certified energy manager, a contributing member of several ASHRAE and AHRI industry committees, and has published several papers and trade journal articles. He holds a bachelor's in industrial engineering from Oklahoma State and a master's in business administration from the University of Colorado. So, Drew, the virtual floor, virtual microphone, camera, and hopefully you can change the slides are yours. Please go ahead.
Thanks, Dan. I need to get to my portion of the presentation and your slides down below. Let's see, is that?
Yeah. So if you have an arrow, just click it to the right.
Yeah.
Or the keys, the arrow keys work as well.
I don't, okay. I don't see my slides in here. Can you point out where the slide number where mine is?
Yeah,
Right there?
it's next. If not, Irene, just take control and Drew.
Oh, there it is. Okay, I got it. I got it.
Okay, that's right.
Hang on. There we go. Okay. Okay, can you see? Is it sharing okay?
No, I see a previous slide. Is that correct, Irene?
Yeah, I still see the previous slide. If not, I can take control again and just say next. I think might work better.
Yeah, sorry, Drew. We will take back control from you, and you just say next, and we will.
Okay, so it's okay. Sounds good.
Okay, just give us 30 seconds. There you go. Just say next. The virtual floor is.
Okay, next slide. Can you get it to advance?
Yeah, so we see the one for Sonderburg Hospital. That is what we have on my screen.
Oh, okay. Okay, it's not advancing on mine. Advancing for the audience. Maybe just a comment.
Yeah, okay, let's just give it a little bit.
It still shows our pictures on my screen.
Okay, so it has a bit of a lag. Presenter has turned off.
Okay. Just from the audience, we are seeing also the one on the Sonderburg Hospital.
Okay. Okay.
Yeah.
I guess it's not you, it's me. All right. Okay, so for Sonderburg Hospital, what we're gonna, it's very, it was a good segue having the last session, because at Sonderburg Hospital, what we're presenting on is a integrated system design, integrated heating and cooling system design, also tied into the district energy system, which is in general what we've tried to do from the sector integration standpoint. Not only integration of the heating and cooling systems for individual systems themselves, but also tied into the district energy system. And the reason for that, and just to kind of give an upfront spoiler or tell you what I'm going to tell you, the reason for that is because of that criticality of addressing the disconnect between supply and demand that comes in with the integration of more renewables into the power grid, and how we're seeing that realized, of course, in Denmark, as the other people on the call that are attending from Denmark can attest to, is the real-time price fluctuation of electricity itself. And how you address that is with storage, and how we can address that on the HVAC sector is in the scale of the solutions that we design and the built-in storage associated with that. And the scale of the solution also enables multiple different other forms of storage. But first of all, the scale of the solution itself, if it is a district energy system, as is the case with the Sonderborg Hospital, it is it's a large scale system applied to a critical facility, which also provides the resiliency of the backup power system. And I'll just be going through a few high level details of that. So in advance of just to mention as well, this is also right next door to where the IEA Efficiency Conference was just held in Sonderborg. And at that conference, of course, we had the comment from the director or the chief of the IEA saying Sonderborg, Denmark is the capital, global capital of energy efficiency. And so this ties well to that recent commentary and event. So at next slide. Okay, everybody seeing the Lighthouse Project slide?
Yes.
Second one. Okay. So this was originally driven by, we have a organization in Sonderborg called Project Zero, which has the goal of driving Sonderborg to net zero emissions near term. And it's very much linked to what we're doing at our own Danfoss headquarters nearby, and a lot of the projects that we're working on there. But this hospital is a fantastic opportunity because, again, it presents that opportunity of showing what's possible for an integrated heating and cooling system and tied into a district energy system on a critical facility, which is, again, from our sector integration view, the best opportunity. Is first of all, kind of flipping the script of focus first on air to water or air to air solutions and the associated efficiency and decarbonization and electrical power and individual user CapEx burden that comes along with those, to focusing on these integrated large scale systems first. And that's where to the commentary on the earlier discussion, where I see that this is the REPowerEU funding is heading in the right direction, is focusing on those because of the efficiency and resiliency and decarbonization potential of them. But in this specific example, and what we've discovered is really critical, public-private partnerships are very much critical, and in this case, the folks that are involved in this project. So moving to the next slide. In the interest of time, I'm keeping it very short relative to the content. So the cooling load in the summer on this hospital is 2 megawatts. The cooling load in the winter is about 1 megawatt at peak and base around 100, or excuse me, with a base load of about 100 or 578 kW. The chilled water loop runs at around 15 to 10 or 15 to 8 in some cases. And then the district heating system ranges between 65 and 75 on the forward, with about 45 degrees C on the return. That move to the next slide, slide number 4, is then segues into the performance of this system. So the performance of this system, and a couple of the things that we like to highlight about this, is first of all that it's really a relatively equivalent or close to equivalent load on the heating and cooling side, which is another reason that it presents a really good opportunity to tie in the heating and cooling system. And this is the case in a lot of cases for critical facilities in general. Data centers are, of course, just purely a cooling load, recovering the heat to the district energy system. But tying the system together in the hospital itself provides benefit for the efficiency of the hospital relative to the efficiency of a boiler applied in the hospital, which is what the heating was provided by previously. And as was highlighted earlier, I think by Jose, Those operate in the area of 0.8 to 1 COP, maximum 1 COP. And as opposed to that, on the winter average heat load day, depending on the forward temperature to the district energy, as shown on the right-hand side, where modeled performance is in the 3.6 to 4.3 COP range. But in addition to that, and one of the reasons that you focus on the integrated system design is because you're providing the benefit of the cooling provided to the critical facility, or in this case, the hospital itself, as well as the heating applied to the district energy system. And if you do the math to show the total efficiency ratio or the symbiosis efficiency of that system, it comes out to 6.3 COP. And that's because of that combined capacity of the cooling provided and the heating provided, divided by the total projected kW draw of the heat pump system applied. So moving to the next slide. In addition to this, what I've highlighted so far, it's also critical for us to showcase what is possible in terms of, or creating a good customer showcase for this. Now, there's been a lot of trade-offs, and the opportunity for funding in the case of this project is a lot of the trade-offs that have been made in getting to where we're at in terms of the scope of the project. And I can highlight a lot of the opportunities for that, but basically what we want to do is maximize the, showing what's possible for an integrated heating and cooling system in terms of decarbonization itself for that facility itself, and then also for the supplying the 100% green heat to the district energy system as well. And how we're doing that, one of the cases, or one of the ways that we're doing that, is by modifying the facility itself to be able to showcase it. And that's what's shown here. And then also on the following slide, slide 6. And what we're planning to do to create that showcase. And what you also see here on the left-hand side is the boilers that are being replaced by the water-to-water heat pumps to provide, again, both the facility, the hospital facility heating, as well as district heating, and then the cooling to the hospital facility as well. Did I keep it to 6 minutes?
You had 8 actually. So.
Oh, 8. Okay. Any questions? Anything that I can address?
I think you can say next slide and see if we have any other slide, because I know you cannot see them on your screen. No, that was the last slide. Thank you so much, Drew. Sorry for the lag that you were seeing them. I think we were one before you. Sorry about that. So thank you so much. Please stay for the discussion that is coming up later. It is my pleasure to introduce you to Jose La Loggia. Unfortunately, we will not.
I'm sorry, but can I ask, just because if we have these 2 minutes, just clarification questions? I think it will help us understand better this project, because I'm sorry, we are not experts in your field, clearly, but I didn't understand, for example, here you were working on refurbishing an existing hospital. So you are introducing more renewable energy into the system, or you're moving to electrification, or both, for us to understand like the greenhouse emission avoidance potential of such a project. That is one question, because sorry, with this project description I didn't grasp that. Then my second question, perhaps more important, would be the replication potential, because you will answer my first question in relation to this specific project, but what would this mean? Like, where can you apply such concept? Will it be only hospitals? I mean, this is huge sector, obviously, across Europe, but what would this mean? Like, I understand this project is in Denmark, but if you move to, say, Poland or Greece, what would that mean? Is this same concept applicable? Will it have the same greenhouse gas emission potential? Because imagine if you apply with this project in Innovation Fund, you need to describe the scalability potential in terms of greenhouse gas emission potential. So yeah, just to understand better what this is about.
Absolutely. Yeah, no, so I'll try to answer that really quickly and I'll set up a follow-up if that sounds good, Maria. So from a quick summary, what you're doing is what we talked about earlier in the panel discussion, right? You had formerly a separate cooling system and a heating system. So electrification of heating and heat pumps is primarily the electrification of heating, right? And so in this case, what you're doing is you're using the same water-to-water heat pump to provide that cooling, replacing the existing cooling system, and then providing the heating, both to the facility and to the district energy system. And so you're replacing, to the CO2 emissions portion of the question, you're replacing the emissions associated with the boilers which were formerly providing that heat. And to the other part of the question, as far as facilities, I keep saying critical facilities. You kind of need to expand on that, right? The biggest opportunity that we see for this, for sector integration, especially in large scale projects, is retrofit of critical facility cooling systems. Critical facilities include hospitals, data centers, industrial processes. Anything that has a backup power system on it, in general, is a critical facility. And there's a number of reasons for that. Primarily, it's also the cooling operating temperatures, but it's primarily the load. They have a load year-round, which in turn means that you can electrify the heating coming off of that cooling, utilize that heating coming off that cooling from that load that is relatively constant year-round. The biggest number of opportunities that we've worked on, that we found, is actually industrial facilities. But hospitals and data centers all present fantastic opportunities. And is it applicable in Poland? Absolutely. But there's a lot of work to do on the forward temperatures in Poland as far as getting those down to provide a really good less than 3-year payback for a water-to-water heat pump system retrofit. But let me know if you're interested in discussing further.
Okay, thank you.
Thank you so much, both. And don't hesitate to ask any questions, Maria, afterwards. That's why we gave the speakers 8 minutes, but they actually have around 11. Don't tell them, by the way. So it's my pleasure to introduce you to Jose La Loggia. You've already seen him in the previous session. He's the president of the commercial HVAC business, which goes to market as Trane, ICS, and Thermocold in the EMA region. For Trane Technologies. In this role, he has full responsibilities for the strategy, operations, innovation, and performance of the commercial HVAC EMEA business. Jose has demonstrated leadership and innovation in roles of increasing responsibilities since he joined the company in 1994. Previously, Jose served as vice president and general manager for the Trane commercial HVAC business in EMEA, where he improved operational efficiencies and led growth within all revenue streams and functions. His leadership has been instrumental in establishing and growing partnerships with customers, suppliers, and partners, which has led to the acquisition of Thermocold in 2017 and ICS Cool Energy in 2018. Jose, the virtual microphone floor and camera are
Thank you.
yours.
I appreciate that, Dan. I'll keep it quick. So we go to the next slide.
Very good.
So I want to talk about what we call applied thermal systems today. So we go to the next slide. So what I show here is it's a very simple pie chart that was created by the Bloomberg NEF, but in discussions with Thomas, I see other organizations within the European Union as well who have come to a similar conclusion. So basically, this pie chart shows the energy use in commercial and industrial buildings in relation to heating and cooling. And what's really striking the first time that anyone sees this pie chart is that really heating, whether it's space heating, process heating, or hot water production, make up 90% of the energy use in commercial and industrial buildings, and cooling only 10%. So the reason that happens is that when we think about cooling is done with vapor compression systems which have SEERs, or seasonal energy efficiency ratios, up to 10, meaning that for every unit of energy you put into that system, you get up to 10 units of cooling from it. On the heating side, the products there, it's full of inefficient products, and the majority of it is fossil fuel-based products, which have a COP of less than 1. And in some cases with older type boilers, the COPs can approach 0.5, 0.6, meaning that for every unit of energy you put in, you only get 0.5 to maximum 0.8, 0.95 units of heating out. So when we look at that as a company, we see basically there a fossil fueled industry that's really due for disruption. And the disruption will happen if we break the silo between heating and cooling, because traditionally in all commercial buildings and industrial buildings, cooling and heating are seen as two separate entities. So you have a boiler plant and a chiller plant. So if we move to the next slide. Next slide, please. Yeah, so the way to look at this then is usually, and it's really interesting because a lot of the things that were mentioned today around, I heard terms like eco-design or, energy efficiency ratings, all these things. All of these ratings are really geared around cooling and heating, right? They're not looking at the thing combined. So we continue to drive for higher cooling efficiencies. And I assume, I'm not in the boiler industry, I assume that in the boiler industry, there is also a push for higher efficiencies in heating. But what we need to do to really break these silos is to think differently, to think about total energy ratio or total efficiency ratio, which is basically the energy that you add your cooling demand plus your heating demand and divide it by the total amount of power that you use. When you look at things that way, you can make a big change. It's no longer incremental increases in efficiency. So if we move to the next slide. So what we've done as a company from an innovation point of view to start that sort of transition or to change this industry is really, we start on the left traditionally. We make chillers, and you see a picture there of a chiller, and that chiller can only do cooling. Then we could make chillers with heat recovery. So those chillers, while they're creating cool water, they can also recover some of their heat and they create hot water, which can be used to base load, any heating requirement. But you can only create that heat while you have the cooling load. We then moved on to create machines that can do heating or cooling. So it's a reversible big applied machine. So it can act like a chiller in the summer, or it can act like a heat pump in the winter and create heat. And the next step of our evolution was to create the same machine, but with heat recovery, so that when it's acting like a chiller, it is recovering some heat. And in the winter, it's just creating heat, right? It's an air source heat pump. And then finally, the last piece of our puzzle to really enable this transition of this industry was to create the machine that can create hot and cold water in any time of the year. So it will basically, if it needs to create heat, it extracts it from the environment. If it needs to reject heat, it rejects it to the environment, and it can create the cold water demand. So what you'll notice about the reason I show this slide is what you notice here is that to the untrained eye, those machines all look the same. And the reason they all look the same, there was a reason for that. The reason for that is that A, we want to produce them all on the same assembly line in our factories in Italy and France. And B, we have a huge network of direct sales people who sell chillers. We want them to be able to sell the combined heating and cooling equipment in the same way they sell chiller to the same customers that we sell chillers to. And finally, when we service this equipment, we have a big installed base of chillers. We want the same service technicians to service the machines that can do heating and cooling. So from a distribution point of view, from a service point of view, from a manufacturing point of view, and from a customer experience point of view, it should be the same. So this has been what we've been doing for the last 5-6 years. If we move to the next slide, I want to talk a little bit about why we're doing this. So if we think about the traditional way, the siloed way that the industry has grown up, you have always a chiller plant and a boiler plant, whether it's a hotel, a university, a hospital, a chocolate manufacturer, a cheese manufacturer. And when I mentioned the total energy ratio, these types of plants, and we have 300,000 plus plants installed throughout Europe like this, When you look at the heating of the efficiency of the boiler plant plus the efficiency of the chiller plant, they have a total energy ratio of approximately 2 when you calculate it on average. So meaning that for every unit of energy you put into that chiller and boiler plant, you're going to get 2 units of heating and cooling out of those 2 plants. When we sell these thermal systems, we start to see total energy ratios that can be over 8 sometimes, meaning that for every unit of energy we put in to a combined heating and cooling plant or a thermal system plant, for every unit of energy you put in, you get 8 units of heating and cooling out. So that is no longer an incremental increase in efficiency that you see in, developing chillers to be more efficient or developing boilers to be more efficient. That's a game-changing efficiency increase up to 400%. The other thing that we see too is that our accessible market doubles in size, basically, because if today we're selling 10,000 chillers, and if tomorrow we can sell 10,000 heat machines that make hot and cold water, we see our markets doubling. So that is our goal. And what's very important for the long term is that when, especially as the electricity grid's green, you can move to a world, and it's very visible to us now, where heating and cooling buildings is basically a zero emission game, because if all the electricity used to run these thermal systems is produced of a renewable grid, then there are no longer emissions related to heating and cooling buildings. So if we move to the next slide. So I want to talk a little bit without disclosing too much, but since in 2020 was basically the first year that we really started to have this thermal system idea in place, with the products in place, with the processes in place to sell and service and convince customers. And you can see that we start to see significant growth, about 30–40% growth. In 2021, we saw 80% growth. And in 2022, we're seeing over 100% growth. So this is what I would call a traditional S-curve adoption. I think with, a lot of people are talking about the S-curve adoption of EVs happening. I think we're going to see a similar thing here, where we're going to see this type of growth really go exponential. What's really required, though, as has been said before during this call, is that we need to continue to build awareness that these things are possible today. We have technology today to make it possible not to have boilers in commercial buildings and industrial buildings. If we go to the next slide, I got some very simple examples of some projects. So for example, this was a Northern Europe type building. It's a museum. This museum had a chiller plant and a boiler plant. They wanted to go gasless. So we recommended that they replace their chiller with a heat pump. And because it's further north in Europe and it's a retrofit, they needed hotter water temperatures. We usually cascade those systems. So we put an air source heat pump or multi-pipe unit in cascade with a water-to-water system. And that means that any time of the year you can provide up to 85 degrees C water. And then the last project I've got here to show another example, next slide, is a hotel. This hotel, again, had a chiller boiler plant. They were modernizing the hotel. We recommended that they move to a combined heating and cooling system. They moved to a heat pump 4-pipe system here. And the other interesting benefit on this example, it reminds me of what Drew just presented, was that when they got rid of their boiler plant, they created a lot more space in their facility, and they were able to create 4 extra rooms from the hotel that they didn't have before. So not only do they decarbonize, save energy, but they were also to be able to create more revenue by creating more rooms in their hotel. So these are 2 examples, but as Drew said, we also have if we talk about hospitals, universities, manufacturing processes like chocolate manufacturing, cheese manufacturing, any manufacturing processes use heating and cooling. These are all valid strategies to move. We just need to break that silo between cooling and heating. So that's it. I hope I'm on time, Dan.
All good. Thank you so much, Jose. It's a pleasure to introduce you to Clayton Vickers, Sales Director, Refrigeration and Heat Pumps, Europe Indirect.
Can I maybe ask another question? Sorry to be like interrupting you again, but of course we are very interested to hear about these new technologies. But I would like to ask in relation to the presentation we just heard. What would be the support that you would need from, say, Innovation Fund or other public funds? Would it be for developing new products or for supporting assembly lines of these products that you have already developed and are quite innovative? Or would it be for supporting raising the awareness through these lighthouse projects like the examples you just gave?
Yes, I would, just to be brief, I would like more sort of awareness, right? We need to build awareness. It's incredible how many people do not know that this is possible. I think if I always use the same example. If I go out onto the street now and I pull 20 people in and ask them, do you know why moving from an ICE car to an EV makes sense? Majority of the 20 will say, yes, we know why it makes sense. If I pull the same 20 people in, and I ask them the question, do you know why having a chiller plant and a boiler plant doesn't make sense and you should combine that? I will not, I'll be very surprised if I get an answer of what is, probably what I'll get is like, what is a chiller plant and a boiler plant, right? And I think about the amount of emissions happening from buildings is probably the same as what's coming out of, ICE vehicles, but it's not seen in the same way or talked about it the same way. So if we could bring the level of awareness up, this would, the growth we're having is good, but it would really accelerate even more. And it would get to my goal of not selling chillers anymore, just selling combined heating and cooling products instead.
Okay, thank you. Very clear.
Thank you, Jose. Please stay for the discussion later. So again, sorry, Clayton, it is my pleasure to introduce you to Clayton Vickers, with over 30 years working within the field of refrigeration and heat pump technologies. Currently working within the Global Products Division of Johnson Controls with a focus on internal programs to deliver products for impactful sustainability. A fellow of the Institute of Refrigeration and qualified mechanical engineer. So, Clayton, the floor is yours. Just say next and my colleague will change the slides, maybe with a bit of a delay. Thank you so much.
Great, thanks, Dan, and thanks for inviting me to this important forum on the topic of extending the application of our industrial heat pump technologies. It's really a pleasure to present this on behalf of Johnson Controls, where we really focused on delivering world-class solutions through our three main brands you see here, Frick, Sabro and York, with factories in Europe for the Sabro and York brands. So if we take the next slide. So just like to reinforce the backdrop, we've covered a lot of this today about the opportunities, and really I wanted to focus today on the opportunities when it comes to industry. We talk a lot around district heating. It is, of course, an extremely important part of our heat pump world. But when we look at industrial heat, we see that, and I see someone don't see the slides. I'll continue and hope that everybody else does. So thanks, Dan. So yeah, when we look at our total heating per annum, the industry demand is 2,950 terawatts, of which 66% of that is process heat. And as you move to that center bar, I think that just reinforces when we're talking around temperatures. So we're really focused on the lower temperatures, and moving current technologies heavily focused and biased towards providing process water below 100 degrees C. Actually 26% of our process heat requirements are between 100 and 200 degrees C. And yes, we do address that market as an industry, but that's the area really where I see the opportunity that we can grow quickly and really help move to decarbonising our heating industry. If we take the next slide, please. So just to take a step back of where we come from, we're talking largely around vapor compression in these discussions today, and that really exploded during the Industrial Revolution, with the first compressor being built in 1880. As we step forward into the post-war era, we see the first heat pump technologies introduced around 1945 in the United Kingdom and 1948 in North America, using various heat sources. And today, we've in the last 5 to 10 years, we've seen water temperatures increase from 70 degrees C up to 90 degrees C, being readily available and commercially available. There are solutions to 140 degrees C, but still really quite new and innovative solutions. And where we see the market grow for the future is really to recognise that there's small and large capacity opportunities. And I think that's really important to reference, that we shouldn't lose sight of a lot of our waste heat are in smaller installations, bridging between the residential to the light commercial to the heavy industry. And if we take the next slide, please. So if we look at where we are today in terms of temperature, and I'm referring here to the Johnson Controls product portfolio, we cater for around from 100 kilowatts up to around 12 megawatts in package systems. That's each individual package systems, and moving up to temperatures in the order of 95 C as a regular standard product. We're offering natural refrigerants, low GWP, synthetic refrigerants, and various compressor technologies. And we know by development of those technologies, we can lead to higher temperatures and even higher capacity. So I think the message here from me is that there's various technologies out there. It's not a one size fits all. We need all of those technologies to deliver on our commitment to net zero. If we can take the next slide, please. So just looking at refrigerant options, I want to talk a little bit around hydrocarbons. This is a project we're currently releasing to field tests. It's being currently tested in our R&D centre in our Danish factory. It's using butane and will deliver water to 120 degrees C. It's actually only providing 500 kilowatts of a total 115 megawatt to this district heating facility. So I think we just put that into perspective, 500 kilowatts of 115 megawatts. If the trial is successful, of course, there will be more heat pumps there. It's being combined with other technologies as well, and using the local ground mines, the existing coal mines, to actually store the heat for the winter use and extract the cooling for the cooling. So really 4th generational of a district heating network. If we'd also look about readiness, the great thing here is with the hydrocarbon refrigerants, we're using lower pressure compressor technology. So well established, well proven since the 1950s. And we're using subcomponents which are already rated to those lower temperatures. Take the next slide, please. So when looking towards hydrocarbons, I included this chart here just to show the critical temperatures for each of these individual hydrocarbons. It means that we can, these refrigerants are available to move up to beyond that 200 degrees C of heating, water need, to 250 degrees C potential. They're natural refrigerants, they're low GWP, and they have a comparable coefficient of a performance of existing heat pump technologies at much lower temperatures. And equally important, being a compressor man, is that the pressure differential is within the current compressor technologies. So we don't need new or more exotic compression technologies. If we take the next slide. So the challenges with hydrocarbons, limited availabilities of subcomponents to push beyond 150 degrees C. That's when we're looking at sealing of the compressors and other even pressure and temperature transmitters, we run into some difficulties. And then because these are oil-based lubricated compressors, we have some challenges with lubricants at these higher temperatures, and we may need to move to other oil-free compressors to push up to that 250. Then looking towards the subcomponent reliability, we do have some concerns there, and we need to the restriction. We talk a lot of restriction about production capacity. It's about access to testing at these higher temperatures. And if we take the next one, please, Dan. So just to touch on other refrigerants we're investigating, we are investigating our trial installations with water as a refrigerant that has the opportunity to go to even higher temperatures. And really, when I look to power to X applications with a higher source temperatures, this could be a game changer for large capacity installations moving forward. And we are also working with synthetic refrigerants up to 180 degrees C. So a lot of work being done privately, but we as a commercial business will focus on the short-term gains and the short-term opportunities, but there's a lot of longer-term, mid to longer-term opportunities also. And if we take the next one, please. So just to summarize, fossil fuels currently provide an opportunity of 600 terawatts of heating between 100 and 200 degrees C. That's a quick get-go to go and get after. We have the heat pump technologies. The barriers to 150 degrees C are already being solved, and we're installing those systems. We need to really work with the subcomponent manufacturers to take the next step, and the testing needs to be accelerated. What's critical also is we see production capacity is competing with district heating, which is seeing an absolute huge increase in demand in the last 6 months. Let's take the next one. Last. Yeah, so I'll leave that open to questions. I see some questions open, so I'm conscious of time, but I'll leave it to the adjudicator here.
Please, Evelina.
Yes, thank you very much. Listening to this presentation, but also to the previous ones, I see that industry is looking lower global warming potential for the refrigerants, different compressor technologies to be able to go to the higher temperatures. I think that not mentioned so often, but there is also the quest for the lowering of the cost, of course, of the final product. And I was wondering, what does it take at the stage of manufacturing to achieve lower cost, have more sophisticated compressor technologies, to use different refrigerants? So all these things to increase performance. I don't know, maybe also something to have more flexible solutions which allow the system integration that previously was talked about quite some as well. But concretely on the stage of manufacturing, of assembly, is it huge investment? Is it different machines? Is it components that you mentioned? What is it does it take? Thank you.
Yeah, and I think that's a really important topic to discuss around. Is it the actual cost of the capital to invest in these technologies? I actually see that the cost is good value for money, and it's about changing the dialogue to total cost of ownership. And what we're competing against currently as an industry is the fossil fuel industry. So gas boilers, which are cheap, all of CHP, which is relatively cheap, and so we need to actually promote the total cost of ownership. And when we can do that, we see that for industries, their investment period, if they move to a 3 to 5 year payback, the product's already in the market to achieve that very quickly. And with the increase in energy costs we're currently experiencing, those paybacks are coming back to a shorter and shorter period, and the removal of any preferential tariffs to fossil fuels will help us electrify the grid, and that will get cheaper electricity with the investments in solar. that will go hand in hand with heat pump technologies.
Thank you, Clayton. I hope that answered your question, Evelina. Irene, next one. Perfect. So it's my pleasure to introduce you to Marco Baresi. He is the Institutional Affairs and Marketing Director at Turboden SPA, company of Mitsubishi Heavy Industry Group. Working in the industrial world, he is actively involved in trade associations, operating in renewable and energy efficiency fields. Currently, he is the Vice President of the European Geothermal Energy Council, or EGEC, and he is also Vice President of Anima Italgogen, the Italian Association for Cogeneration and Waste Heat Recovery within coffee industry. He actively cooperates with multilateral development banks such as the World Bank, EBRD, and IDB. Now, Marco, unfortunately, we couldn't put the new presentation that you have. So tell me if the changes are too big, or if not, we just go with the older one that we received a few hours ago, as you wish.
No, in my opinion, we can use that and we jump. So thank you.
Thank you so much. So just say next slide, and keep in mind there might be a little bit of a lag when you say next until it changes.
Yes, thank you. In less than 8 minutes, I'd like to share the experience of Turboden as a European manufacturer of ORC, organic ranking cycle mainly, and large heat pump. The next slide, please. Okay. Only a few words at the beginning to introduce Turboden that helpful for the discussion later also for large heat pump. Turboden is an Italian firm started in 1980 and specialized in turbines manufacture, organic ranking cycle, a closed loop system for distributed generation, mainly for geothermal, waste heat recovery from industrial processes and biomass. Thanks to this experience, we started to manufacture large heat pump. Turboden in 2013 becomes 51%. Mitsubishi acquired the 51% of Turboden in 2013 in order to become a worldwide player in this field. Currently, is important, in my opinion, to underline, we are an Italian manufacturer, but we are the reference company in the Mitsubishi Galaxy for the organic ranking cycle system that are engineered and manufactured in Italy, and also an R&D special facility in Milan. The next slide, please. R&D and innovation are in our DNA. Turboden is a spin-off of Technical University on Milan 40 years, more than 40 years ago. And we are specialized in more than 60 European different turbine manufacturers in the range of few megawatt to 20 megawatt. And why is so important? Because the new compressor for large heat pump shares a number of technological features and solutions with Turboden turbines. The second chapter is related to the working fluids. Currently, we are experienced, as I told in the previous discussion, we are experiencing with 10 different working fluids. And some of these working fluids are used with high temperature because we are experienced with high temperature working fluid, for example, for biomass, but also for waste heat recovery in industrial processes, and also low to medium temperature experienced in, for example, for geothermal. Direct heat exchange, it means that we are not specialized only on turbines, but we couple our turbines with industrial processes. We are experienced with more or less 40 plants in operation recovering waste heat in different sectors like steel, cement plants. So we are experienced in couple our turbines energy efficiency solutions with industrial facilities. Next slide, please. No, is another one, please. Yes, currently we are present in 50 countries, but is relevant to go ahead, please, with the next slide. Why heat pumps is the key question today, because they play a key role in the electrification of heat and increasingly decarbonized power grid. We are focusing on two different heat pumps. For district heating, so low temperature heat pumps, and high temperature heat pumps for energy intensive industries. Next slide, please. This is a market potential that we elaborate internally. As I told you, we are focusing in these two different areas, and this is a simplified scheme for internal study. It's relevant to see that the very high temperature heat pumps currently is missing in the market, so is a gap to cover. So is a reply to the question of Maria Velkova, why Innovation Fund could be helpful. Could be helpful, for example, to cover this gap. Next slide, please. Yes, this is another internal elaboration concerning why the large heat pump is competitive compared to other solutions, for example, compared to green hydrogen for the future, but also if you see the red line in this area, compare with gas boiler. The low line is related to gas boiler, considering the cost of CO2 related to zero. And the upper limit for the gas boiler is comparing the CO2 cost in the range of 100 euro per tons. So it means that all these areas are helpful to cover with large heat pump this area. Next section, please. Okay. This is a concrete project. We are in commissioning phase thanks to the LIFE program. LIFE program is well known in DG Climate. We are developing a waste heat recovery system with a large heat pump in an energy intensive industry with other partner. Next slide, please. This chart shows what we are developing. In the next weeks, we will do the first kilowatt hour for the large heat pump. Basically, starting from the electrical furnace in the steel industry, in the secondary circuits, we recover the waste stream at 75 degrees, and thanks to a large heat pump, we put this heat increasing the lift to 95 up to 120 peak for the district heating in the city of Brescia. The three main points. One is the size of this large heat pump is a 6 megawatt thermal large heat pump. The second is height flexibility with 2 compression stage. And the third point is related to the working fluid, is the low GWP refrigerant. Next slide, please. Going deeper in the and trying to reply also to the question of DG Clima, which is the role of Innovation Fund. Turbodel large heat pump developments is focusing in large scale, 3 megawatt to 30 megawatt thermal per unit, high temperature lift with a delta T up to 80 degrees, and high temperature output including steam generation. And also various field of applications. So the technology developed for geothermal are helpful also, for example, for other applications. And we are focusing on biomass, waste heat in energy intensive industries, waste to energy, and power plants. Next slide, please. This final part is related to the future development. So geothermal will play a key role also for us, also for the URC, but also combined with the large heat pump. And this is a study for the future development connecting the geothermal, so the exploiting of the heat from the underground, in this case 140 degrees, coupled with ORC. to generate power, clean power from geothermal, and this clean power could be helpful to feed a large heat pump, for example, for a district heating. Next slide, please. Large heat pump could be the previous one, please. Large heat pump could be also helpful to be connected with a CHP gas engine, for example, fed by biogas or hydrogen in the future, exploiting the potential for geothermal heat sources, coupled with, for example, with greenhouse. Also, in this case, connection with district heating for the low temperature streams. Next slide, please. And this is the future development related to the industrial park. So, as I told at the beginning, we are focusing in high temperature heat pump delivering steam. In this case, for example, is an example of industrial symbiosis. We can start from industrial site to increase the leap and to deliver the steam to another industrial user close to the previous one. Next slide, please. So that's all from my side, and I am open also for the question related to, for example, the innovation, the role of the innovation part for the future development. Thank you.
Thank you, Marco. Are there any questions I have to ask before now? No, I will go ahead. It's my pleasure to introduce you to the last speaker of the session. Parfait is the head of tendering at Enertime, an industrial SME with a unique positioning as manufacturers of free CO2-free energy recovery technologies, ORC systems, heat pumps, and gas expansion systems. Previously, Parfait worked as a pre-sales engineer for a vacuum technology solutions manufacturer for process industries. So we can see you. Just say next slide, please. And keep in mind, there's maybe a slight lag between when you say next and when it actually changes. Please, the floor is yours.
Thank you, Dan. As I think so. So thank you all of you for this very interesting discussion that we have been having since at the beginning of this afternoon. A lot has already been said on the main challenges among us for the wide development of large-scale heat pumps. So I will just thank you for this opportunity which is given to us at any time to add something to the topic from the technology developer and manufacturer perspective. So I will, if you allow me, try to share my screen if that works.
No, say next, and we will. Okay.
Is it okay? Can you see my screen?
Yeah. Okay, it's fine. Thank you.
Okay, perfect. So let's start then. So few words on Enertime about us. So Enertime, we are on industrial SME created in 2008, and we are listed on the Paris stock market since 2016. Originally a turbo machinery designer and manufacturer, which by the way makes us proprietary of our patents on turbines and compressor. And that gives us a certain flexibility for tailor-made and scalable solution for our clients. Yes, so we quickly evolved as a designer and manufacturer of three CO2-free technologies, which are ORC systems, heat pumps, and also gas expansion systems. Our total installed capacity on ORC is 25 megawatt electrical implemented all over the world. So that also, you know that we also come from the heat side of the heat recovery with heat recovery solutions. And more than 50% of our turnover comes from the exports. So regarding the energy efficiency market and with the ambitious objective for the decarbonization of the European industry, and also considering this insecure context of rising prices for electricity and natural gas We strongly believe that large-scale heat pumps, as well as, of course, other innovative technologies, of course, have a role to play, if not solving, but at least bringing some solutions to those issues. So, as an time, we have identified three main drivers, which are the resource, some key parameters or factors related to projects, and finally the targeted market. So for the resource, for industrial high temperature heat pumps, we have identified process, flow gas, low-grade steam, and also cooling loops, for example. And for large-scale district heating heat pumps, it will be grey water or seawater. Now, regarding the projects, we believe that some key factor in a project for heat pumps will be the source and demand adequacy, the profitability, the long-term vision, and also the funding or grant availability for those projects. And if you look at the target market for an efficiency and wide development of the technology of heat pumps, we have identified that industry with direct steam production and district heating and greenhouses for high temperature hot water production are the main topic that will have a certain impact on reaching the target objective that we have among us. So for the industry, and an illustration of our strategy with the heat pump and also of our positive dynamic is the success in our participation as a technology provider to this European funded program Push to It, which is also part of the Horizon program. So the aim is to increase energy efficiency of an industry through the recovery and upgrade of waste heat, which for this case is direct steam production at around 4 bar with a heat pump. The industrial site which hold the demonstrator is a paper manufacturer in Italy. And yes, for this project, we have more than 10 industrial and academic partners in more than 7 countries. Another objective of this program, Push to It, is also to identify and overcome the barriers for the wide development of heat upgrade technology, such as high temperature heat pumps. And we know that the technology already exists, but there are still some different technical or non-technical barriers which limit their wide implementation. So we will seize the opportunity with this program to try to propose and to go over all these limitations and propose solutions to overcome them. So in continuation to Push to It, REPowerEU EU represents a real opportunity for the implementation toward industrialization. For example, more than 100 pressurized water large scale heat pump. We have identified that a minimum size of 5 megawatt to a maximum of 20 megawatt tailor-made multiple heat pump solutions using low temperature source like seawater or mine water or wastewater can be a very sensitive market, or up to 4 bar steam large scale tailor-made heat pumps solution combined with MVR also could represent an opportunity that would link to a very interesting development. Rough numbers on GHG emissions avoidance will be, for example, 200 kilowatt of CO2 per megawatt replaced by 1/3 of 60 kilogram or 20 kilogram CO2 per megawatt hour emitted by the French electricity mixed. And the project maturity at any time is for commissioning close to 2025. There is also a scalability introduced by the huge market potential and also depending on the application, of course. a cost efficiency, for example, for 1 megawatt, if it has to be evaluated based on the 4,000 hours of operation. We give, for example, 4 gigawatt thermal and saving of around 720 tons of CO2 per year. So that was it for NI time. Thank you very much for your attendance.
Thank you, perfect. I'll ask Irene to start sharing the screen again at the session of group discussion, and I will just highlight a little bit that we are about 15 minutes behind schedule. So please, would the speakers like to put their cameras on as well? And I will leave it to Evelina, and my colleague will be working on sharing the screen again.
All right. Let me start. I think that we can get organized in such a manner that, first of all, if there is any pressing question from the floor, I keep my eye on the chat. So whenever I see a new question, because I think that the previous one up to this moment were more or less answered. So for the new questions, I keep an eye and I will raise them to the attention of the speakers. And just before those new questions come, I would take the liberty to take the floor on just to sum up a little bit that we heard about plenty of interesting projects today. I think that there could be eligible for the Innovation Fund, especially the main window, because it was about the fitting of the heat pumps or the combined heating and cooling systems into the industrial facilities. So this is extremely interesting. We keep fingers crossed, first of all, for the projects, and I think that we have also an interesting pipeline for the Innovation Fund, of course, to be seen what kind of applications are made. Now, just to go back to the original reason for this workshop, it is that we, for the first time ever, will be launching a window for manufacturing. So before you come with those solutions to be fitted in the industrial context, and also, of course, in the residential sector, you have to manufacture them. And I would have a question actually to all the speakers. If you could have support from the Innovation Fund for the innovative aspect of manufacturing, be it in terms of manufacturing process itself or the product that will be manufactured, what would it be? What would be the main focus? Is it about refrigerants? Is it about the embedded flexibility? Is it about some very new, brand new compressor technology? So think about manufacturing, because this is this new animal that we have under the Innovation Fund. And if there could be a match between the projects you are promoting and this possibility.
I'll speak to that one if I can, if that's okay. This is Drew Turner. The critical factor from a manufacturing standpoint for these large scale combined systems is, especially when you're tying into a district energy system, is a turnkey solution. And so what that means is packaging not only the water-to-water heat pump solution itself, but as much as possible the hydronic system around it, and making it a turnkey solution that can be started up very quickly. Because of the complicated nature of these systems otherwise. So what you try to do is balance out the complication of these systems by pre-packaging as much as possible. And so that's how we would apply. That is into facilitating not only the water-to-water heat pump itself, but the larger hydronic system and the pre-packaged turnkey solutions get around it.
Understood, very clear.
Yeah, maybe I can go next. Yeah, certainly the fully packaged solution on a turnkey situation, as much as we can make it plug and play, is what we're looking to do to make it easier for the adoption. I do think as we move the technologies forward and really push the boundaries towards higher temperatures and different refrigerant choices, and different working fluids. There is an element of work to be done there on the testing. And what we can take is a learning from the past is we don't do that extensive testing and then the extensive field trials. Then we can run into problems with the technology moving forward, and that will actually slow the adoption. So what we would look for is that support in new technologies, testing, and also the development of shall we say more novel solutions when it comes to material technologies, additive technologies. There's a huge sphere of work that can be done to help speed up this implementation.
May I have a follow-up question on this? When you say testing, does it mean still lab testing, or within the company own research facilities, or does it mean testing that you go immediately to the location and then you see how it works? Because through all these projects, at least myself, also not the biggest expert on the heat pumps, I really got the impression of being specific to the location, to the solution sought. So yes, the initial piece of machinery is maybe standard, but then the devil is actually how it is fitted into the specific location. So which one was meant by the testing?
Yeah, so when we talk about lab testing, we have a lot of testing facility available for our traditional technologies at lower temperatures. For example, in our factory in Denmark, we have 12 different testing bays for use with ammonia refrigerant and CO2. So we can do the pre-field testing there. When we're looking to go to more innovative solutions, then to get those adopted quickly into the marketplace, we need to either upgrade that testing facility, which is not difficult because there's no substitution for putting run hours on a machine. So then you're looking at testing in the field, and that to me is where there's an opportunity for further support.
Thank you. Very clear. Marco, I think you have further answers to this.
Yes, thank you. I agree also for the necessity of testing, but in my opinion, we basing the fact that innovation fund is related to ITRL. So what we need in this phase is to do project, make awareness of this kind of technology is also is also based on the fact that we have project to demonstrate. So in my opinion, we have to push to have a project in operation for the low temperature district heating, phase, but also for the high temperature. As I told at the beginning, we need volume in order to decrease the cost. And also there are the needs of innovation that could be addressed, for example, in Horizon related to the development of new compressor or so on for the medium to long term time. But in this short time, REPowerEU is related to short term. In my opinion, we need to do to facilitate the development of project in industrial size, in coupled with renewable. For example, I gave you some example in geothermal, and this is what relating. One of your questions, for example, I'd like to share the experience we had with the UK, for example, or with the Department of Energy in the United States, related to the fact that they realized a sort of database in UK is called ETL, in our Energy Technology List, from the base. So basically, a sort of list of technology eligible and available for the public. So in my opinion, could be helpful to do this also for industrial heat pump in order to make potential customer and people from industry to know technologies and to give access to the details.
Yes, and I think it goes also with the previous comment made in the discussion about awareness raising, being aware also by the industrial players that such solutions are available. Fully agreed. I don't see other speakers raising their hand. I don't see questions on the chat. So let me ask you one more question from really perspective of Innovation Fund operation. The way that application has to be made for Innovation Fund is that you have to demonstrate the cost that you have. And part of this cost, like Maria was explaining at the beginning, up to 60% of those costs, called relevant costs, can be indeed covered by the grant. So there also has to be other sources of funding. And one way of presenting such cost is to say, if I do innovative heat pump, I have higher cost than standard heat pump already available on the market. Our question is whether there is such a knowledge, whether in such a diverse industry, I think we got a very good taste of this today, is it possible to know even if you come with an innovative product, whether it is comparable to a similar product and you could demonstrate the higher cost, which would be a cost of being more innovative, and for which you could possibly make a case that it is to be covered by a funding program like Innovation Fund. So just really to understand, my impression from today, it is very diverse sector, but maybe it's misconception only after the workshop. So could there be a standard product to which you would compare more innovative products?
Okay.
Yeah, I think this is an answer to that question. What we'll frequently do on these sector integrated cooling and heating system, large scale system opportunities is compare it to what would be the associated infrastructure and operating cost scenario of using individual air-to-air solutions to provide heating and cooling. Is that the kind of benchmarking activity that you're speaking to that would be of interest?
Well, we have two benchmarking activities. One is on GHG emissions, and one is on the costs. So I think what you describe is, if I understood correctly, is more like comparing. Okay, what if I had a standard heating and cooling solution? What is the savings in terms of GHG emissions that my solution is bringing? So that's in the GHG realm. My question was more on the cost side, but I'm not sure I heard exactly what you said as comparison. So it is innovative heat pump with just summarizing what I heard at the workshop today, with refrigerant, with the low green global warming potential, and the one which is very flexible for all the possible applications. It would have possibly higher costs than the standard one today available on the market. So I'm wondering whether this comparator, whether this benchmark is readily available knowledge in such a diverse industry.
It's available knowledge. It's case by case, but we can definitely provide examples of case by case comparisons that have been done. And it's not a consistent comparison. In other words, sometimes if you wanted to do it in the traditional way, it's going to be lower cost, and sometimes it would be higher cost. So there's that caveat, I guess. But we can definitely provide those.
Okay. Yeah, you confirm a little bit that it is case by case, that there wouldn't be one product that is an easy benchmark for all the solutions. Huh? Okay. Yeah.
Yes.
And
sorry. If I can add something, I agree, is case by case, and also is relevant to understand for industrial processes that in some cases there is no comparison, but with other similar heat pump project. But the comparison could be, for example, with gas boiler, and so this makes sense to take into consideration.
Yes, I heard you well. This is indeed impression that I also have after this workshop, that it could be sort of lowest common denominator to compare to the gas boiler. Understood. Okay, I think that there was also a comment on the chat from my colleague Eric Lecomte. reference could be, Eric, would you like to explain your idea?
Evelina, I'm not sure they can speak actually. Some of the attendees are not able to switch on their microphones.
I think what he's suggesting is if you're going to do it for an integrated system versus an individual cooling and heating system, it's a cleaner, easier one to do. So just take for example, industrial facility where you're utilizing the cooling for the process or the facility, and then the heating for the process or the facility, and just do that separated system versus that integrated system design comparison. And that is one example that we've done.
That could be also a solution. Yeah, I see that. And I think, Dan, you say you allow the mic now to Eric, so I don't know if he still wants to come in on this point.
Yes, indeed, that's what Drew just said, that the easy solution is the cheapest one, especially in terms of investment, the chiller and the gas boiler. But if you replace by a more integrated system, the initial cost will be higher. And maybe due to the infrastructure that has to be put in place, that the payback time is not sufficiently short to be completely cost competitive, and that's where the support could come in place. Yeah.
Thank you very much. Very useful. I don't have other comments from the floor, so I think also in the interest of time, really the last question for the speakers, also a bit stemming from the previous discussions on the pipeline of the projects, because we heard about you saw the results of our survey. I don't think that we reached out to all the players in the field. That's the best effort that we can have on the European level. You were speaking about very interesting projects, but if you could make differentiation, what are the higher needs? Is it for the operation of manufacturing facilities which can produce already well-established projects? Is that the main need, or is it still for the refurbishment of the existing manufacturing capacities to come up with more innovative ones? In the light of objectives in the REPower communication, is it the products which are already established on the markets which are in higher need of the investment needs, or still you think it is more related to the innovation to come up with the more performant products?
Yeah, maybe I could take a first stab at this one. Look, both are important. We're seeing a lot of retrofit activity, particularly in certain vertical markets, such as food and beverage, but there is a real need for more products and wider acceptance and lower cost products for the higher temperatures. And when I say higher temperatures, I'm still talking in the 100 to 140 degrees C range. And that really falls across the energy verticals, and also, such things as paper and packaging. So yeah, there's equal need and equal demand, but certainly in the last 3 months, demand has accelerated exponentially, I would say.
Yes, and in your presentation, I was also quite intrigued by lack of components. I think it was in your presentation, it was also mentioned that maybe not lack, but readily full availability of components. At least there was a question mark on this. I guess that related to those more sophisticated compressor technologies and the high temperature possibilities, right?
Yeah, correct. I mean, a lot of the lower temperature, lower pressure, traditional refrigerants and working fluids have been well proven over decades, and some of that development work has taken decades. So to accelerate into a 2 to 3 year window to higher temperatures, we will need a real effort, not only from when I talk around heat pump component suppliers, but really looking at the subcomponent level and material technologies. That would be some of the biggest barriers to entry at pace I would see currently you know, a lot of the technologies we're talking about, the physics and the theory has been well established for many years. It hasn't been implemented because the demand wasn't there, and we need to do a lot of work now to catch up.
Thank you. Any further thoughts on this question between the production of more innovative products and those already established on the market? Then I guess that the rest agrees with John. Very good. I think that we are anyways at the end of the event, more or less time wise. One last call for the comments, questions. Yeah, I don't think I see any raised hands. So Dan, over to you. And since I still speak, big thanks to all the speakers from my side. I learned a lot, very interesting presentations, and very useful for us for the operation of the Innovation Fund. Thank you very much.
Thank you so much indeed. And many quotes that we have noted and we will put in an article. However, I would love to end the event now, but of course, we want to end it as the agenda says. And I call to the floor Philippe Dumas, which I hope he is still here, and I hope his microphone and camera are working. He is. Thank you so much, Philippe. So I take it for, I give it to you to close the event, and I echo your thoughts, Evelina, in thanking all the speakers and participants for being here today. Thank you.
Indeed, a big thank you also from my side, from all the speakers. Thanks for the Open Commission to give us this way to co-organize this event, EHP EJEC. Indeed, it was useful, but maybe we have to remind a bit the context. No? So here we speak about the third call of the Innovation Fund. We have some lessons learned now from the first and second call. The rate was quite low. Now we speak about less than 5% for large scale and 10% success for the small scale. So indeed, we welcome the lessons learned. Also, you take into account for designing this third call with dedicated topics. And manufacturing, we see these 4 areas, but of course there's still question mark. We hope that doing this workshop will help you to answer some question mark about the boundaries. Now we have to see to fix for being sure that the applicants, also the market actors, are not losing time in doing application that after are not successful. So it's both interest of the market actors and the Open Commission that there's good proposal and successful funded projects. So what we can see is that indeed we have not been able to answer all the challenges. So can we suggest to the Open Commission that both EHP and EJEC will play a role of a channel if further inputs can be forwarded to you, because we understand that you are still in the process of designing the tender specification for a call to be launched end of the year. No? It's what we have seen. So there's still some times maybe to further send you some inputs if they are needed. I see, Maria, you want to intervene, so maybe it was yours.
Well, maybe on the spot, yes, indeed. We welcome very much that you channel all the comments because we will be unable to judge which comment is more important from the perspective of the sectors than another comment. So we really will appreciate that you actually collect the comments and then channel them to us more in a summarized form. And maybe we can even offer to you, to the 2 associations, to have a follow-up meeting, a closer one, like with the outcomes, all the input that you have collected. Also, we can discuss what we heard at the beginning. I didn't want to intervene because it's not the time to explain how the first calls, how the projects, for example, from geothermal or another renewable heating and cooling fared in the first calls. It's not the point to discuss today, but we will be happy actually to discuss all these actually findings, so perceived findings from your side and how we see them.
No, indeed. Thank you, Maya, for this opportunity. Indeed, we will welcome to provide you further input. Indeed, in terms of boundary, we see that large heat pumps as a big future. We see it's a big market to decarbonize our economy to reach climate neutrality by 2050. We mentioned opportunities in agro-food industry, in greenhouses, and it's key. It's certainly key for energy. It's key for food security today in Europe. So indeed, we are going beyond just supplying heating and cooling for energy issues, but also for food security, which is important for decarbonizing the industry, for decarboning or district heating and heating and cooling systems to the building. So large heat pumps, it's really welcome to have this heat sector, because indeed probably today is still at the infancy in a market development stage, but it's important to keep this industry in Europe, to reindustrialize Europe. And we really thank the Commission to give this opportunity, but we remind that it should be successful also for the industry. So really, we need all of you participants today. I saw that we are more than 100 participants to provide your input, because it's helpful also for the Commission to have a good criteria for you to apply. I will not be longer because time has run, but thank you, Dan. Thank you, the HPA team, for calling this event, and I wish you a good end of the day.
Thank you so much, Philippe. Sorry we went over time. Always a pleasure having you here. So with that being said, and the last slides, scan that QR code, follow us for the new events that are upcoming, follow EHPA, EDGEC, and of course the European Commission on their way towards the Innovation Fund. And with that being said, the last slide being, thank you for attending our workshop. Sorry, it was a bit long, but I'm pretty sure we could have made it like all our other events even longer. Thank you to my team, especially Irena, that was here and saved the day with her backup copy of the presentation. And I hope to see you soon at our next events, and we will keep in contact. Thank you so much for this opportunity, speakers and moderators, and see you all soon. Have a pleasant evening. Bye bye bye.